Picture this. It's Friday, October 3rd, 2025.
Before impact.
While most of humanity
from
goes about
Mars's
their mundane
castles.
routines, grabbing coffee, checking emails, complaining about traffic, something extraordinary is happening 30 million kilometers away from Earth. An interstellar visitor, a cosmic anarchist that has been hurtling through the void between stars for 30,000 years, is about to conduct the first real test of human civilization's vulnerability to threats from beyond our solar system. This isn't science fiction. This is 3I Atlas, the interstellar comet that's turning every assumption we had about Mars, our next home, our backup planet, our insurance policy against extinction, into something far more unsettling. What makes my pulse quicken isn't the distance of 30 million kilometers between Atlas and Mars. At roughly 75 times the distance between Earth and Moon, a direct collision is astronomically improbable. What keeps me staring at the data late into the night is this. The worst-case scenario might not involve Atlas hitting Mars at all. It might be something far more subtle and potentially permanent. Here's what we know for certain. Atlas carries ice and chemistry forged under an alien sun, materials that have never existed in our solar system. It's generating a carbon dioxide coma of surprising proportions, with erratic brightness surges that appear without warning and vanish just as suddenly. The European Space Agency and NASA are tracking it with every available instrument, the James Webb Space Telescope, SphereX, and our entire Mars surveillance network, including the Mars Reconnaissance Orbiter and Perseverance rover. But here's where the scenario becomes genuinely unsettling. The most critical moment of this encounter coincides perfectly with solar conjunction, a period when Mars disappears behind the Sun from Earth's perspective. We're essentially flying blind during the cosmic equivalent of a high-stakes poker game, trying to observe through a keyhole while wearing a blindfold. The timing seems almost deliberately orchestrated, as if the universe has a twisted sense of humor about testing our preparedness for interstellar threats. Yet this raises an even more disturbing question. What if we're looking at this all wrong? What if the real test isn't whether Mars survives Atlas, but whether humanity can distinguish between genuine cosmic threats and manufactured crises? In an age where "don't look up" scenarios feel increasingly plausible, Atlas might represent something far more dangerous than a rogue comet. It might be exposing our collective inability to process existential risks rationally. Consider the metaphor that haunts me. Mars has always been sold to us as humanity's next chapter, our planetary insurance policy, the red sanctuary where we'll establish our multi-planetary civilization. But what if Atlas is about to transform Mars from our next home into our greatest warning? What if this Friday in October becomes the day we realize that even our backup plan is vulnerable to forces we can't predict, can't control, and can barely observe? The rational mind says 30 million kilometers, minimal impact probability, business as usual. But the part of me that understands how the universe actually works whispers something darker. Atlas isn't just another comet. It's the first real test of whether humanity is ready to be a multiplanetary species, or whether we're still just clever primates playing with rockets while cosmic anarchists decide our fate. This is where the investigation begins, not with the comfortable certainty of orbital mechanics, but with the uncomfortable realization that Atlas might be teaching us something we're not ready to learn about our place in a universe that operates by rules we've barely begun to understand. The European Space Agency first detected Atlas in January 2023, when it was still beyond the orbit of Saturn. Initially classified as just another long-period comet, the object's true nature became apparent only when spectroscopic analysis revealed chemical signatures that didn't match anything in our solar system's catalogue. The ice wasn't just frozen water and carbon dioxide. It contained organic compounds that had been exposed to cosmic radiation for millennia, creating molecular structures that simply don't exist in our local stellar neighborhood. What makes Atlas particularly unnerving is its behavior pattern. Normal comets follow predictable outgassing patterns as they approach the Sun. Their tails and comas develop gradually, following well-understood physics of sublimation and solar wind interaction. Atlas has been throwing what can only be described as cosmic tantrums sudden brightness increases that suggest massive outgassing events, followed by periods of relative quiet that make no sense given its distance from the Sun and expected heating patterns. The mathematics of Atlas's trajectory tell a story that should concern anyone thinking seriously about humanity's future in space. This object has been traveling through the galaxy for 30,000 years, longer than human civilization has existed. It carries within its frozen core a chemical history of interstellar space that we're only beginning to understand. When those exotic ices begin sublimating in our solar system's warmth, they're not just creating pretty light shows. They're potentially introducing alien chemistry into our neighborhood for the first time in recorded history. But here's where the timing becomes almost supernaturally problematic. Atlas's closest approach to Mars occurs just 3 weeks before its perihelion passage. This means the comet will be at peak activity, maximum outgassing, highest probability of fragmentation, most unpredictable behavior, during and immediately after its Mars encounter. If Atlas decides to disintegrate or experience major sublimation events during this period, Mars could find itself in the path of exotic debris, traveling at interstellar velocities. The conjunction period that blinds us during this critical encounter transforms what should be a routine astronomical observation into something resembling cosmic Russian roulette. Our most sophisticated Mars surveillance network, orbiters worth billions of dollars, rovers that represent decades of engineering advancement, communication systems that connect us to our backup world in real time, all become useless for weeks precisely when we most need to understand what's happening to the planet we're planning to call home. This isn't just about Mars, though Mars is where the immediate drama unfolds. Atlas represents humanity's first encounter with genuine interstellar chemistry since we became a technological civilization. Every previous comet we've studied originated in our solar system, formed from the same basic materials and chemical processes that created Earth. Atlas brings something genuinely alien, not in the science fiction sense of artificial intelligence or deliberate communication, but in the much more fundamental sense of matter that has never been part of our local cosmic environment. The implications extend far beyond this single encounter. If Atlas represents a typical example of interstellar objects that occasionally wander into our solar system, then our entire approach to planetary defense and space colonization needs fundamental revision. We've been planning Mars colonization, assuming that the main threats to planetary habitability come from predictable sources: asteroid impacts, solar radiation, volcanic activity, climate change. Atlas suggests we need to factor in the possibility of exotic contamination from visitors carrying chemistry that we can't predict or model. This is where Atlas transforms from an interesting astronomical object into an existential question about humanity's readiness for multiplanetary civilization. Are we prepared to establish permanent settlements on worlds that might be vulnerable to contamination from sources we can't control or even properly observe? The conjunction period that conceals Atlas's encounter with Mars is a perfect metaphor for the broader challenge. We're trying to build our species' future in space while operating with fundamental blind spots about the cosmic environment we're entering. The cosmic anarchist has arrived at the worst possible moment in human history, advanced enough to detect the threat, committed enough to Mars colonization that the stakes matter enormously, but not yet sophisticated enough to defend our backup world against chemistry that operates by rules we're only beginning to understand. Atlas is testing whether humanity deserves to survive among the stars, or whether we're still too primitive to recognize the warnings the universe is sending us about the true nature of cosmic citizenship. Let me tell you what genuinely troubles me about Atlas's composition, because this isn't your garden-variety dirty snowball that formed in our solar system's comfortable, predictable chemistry set. The spectroscopic signatures coming back from the James Webb Space Telescope reveal organic compounds that have been marinating in the radiation environment of interstellar space for 30,000 years. We're not talking about familiar carbon-hydrogen chains or simple amino acids. We're looking at molecular structures that were literally cooked by cosmic radiation from multiple star systems, creating chemistry that has never existed anywhere in our solar neighborhood. Here's the detail that makes my hands shake when I'm reviewing the data. Carbon dioxide isn't just a simple gas that creates pretty comet tails. At the right temperatures and pressures, CO2 becomes an extraordinarily effective solvent for organic compounds, arguably better than water for dissolving and transporting complex molecular structures. Atlas's massive carbon dioxide coma isn't just visually impressive, it's potentially the perfect delivery system for whatever exotic biochemistry this interstellar wanderer accumulated during its 30-millennium journey between stars. The European Space Agency's preliminary spectral analysis reveals organic signatures that don't match anything in our databases. Not just different concentrations or isotope ratios, completely novel molecular architectures that suggest chemical processes we've never observed. These aren't variations on familiar themes. They're entirely new symphonies composed in the radiation environment of deep space, where cosmic rays and stellar winds create chemical reactions impossible under planetary conditions. But let's step back to examine the rational explanation for a moment. Organic chemistry follows universal laws regardless of where it occurs. Carbon, hydrogen, oxygen, and nitrogen behave according to the same quantum mechanics, whether they're on Earth, Mars, or in interstellar space. Complex organic molecules are actually quite common throughout the universe. We find them in meteorites, interstellar dust clouds, and even in the atmospheres of other planets. Atlas might be carrying exotic compounds, but exotic doesn't necessarily translate to dangerous. Yet this is where the physics becomes genuinely disturbing from a planetary protection standpoint. Mars, with its dead magnetic field and tissue-thin atmosphere, stands essentially naked before any chemistry that Atlas might deliver. The planet's surface chemistry is dominated by perchlorates, highly reactive compounds that could catalyze interactions with exotic organics in ways we can't predict or model. Mars isn't just vulnerable to contamination, it's primed for chemical reactions between 4.5 billion years of Martian evolution and 30,000 years of interstellar biochemistry. What if we're witnessing the first documented case of interstellar panspermia in reverse? Instead of life spreading from planet to planet within a solar system, we might be watching alien chemistry from another star system potentially, contaminating our backup world. The implications are staggering. Mars could become biologically compromised, not by human contamination, but by exotic biochemistry that we can't predict, can't control, and might not even be able to detect with our current instruments. The timing of Atlas's approach makes this chemistry scenario particularly insidious. The solar conjunction period means we'll miss the initial chemical interactions entirely. When Mars emerges from behind the Sun in late November, any exotic chemistry that Atlas deposited will have had weeks to interact with the Martian environment. We'll be analyzing the results of chemical reactions, not observing the reactions themselves. It's like walking into a crime scene hours after the event and trying to reconstruct what happened from the remaining evidence. Still, the skeptical voice in my head points out the obvious. Space is mostly empty, distances are vast, and the probability of meaningful contamination at 30 million kilometers is vanishingly small. Most of Atlas's coma will dissipate harmlessly into the cosmic void, and Mars will continue its billion-year journey around the Sun completely unaffected by this brief encounter with interstellar chemistry. But here's what makes this scenario particularly unnerving. We won't know. Mars's thin atmosphere means any contamination would spread globally within months through the planet's notorious dust storms. Unlike Earth, where weather patterns and ocean currents might contain chemical contamination to specific regions, Mars's atmospheric dynamics would distribute Atlas's chemistry across every future landing site, every planned colony location, every terraforming experiment we're hoping to conduct. Consider this darker possibility. Atlas's exotic chemistry doesn't create immediate toxic effects that we could easily detect and respond to. Instead, it creates subtle chemical changes that gradually alter Mars's atmospheric and surface chemistry over months or years. The planet slowly becomes biologically incompatible with human physiology without any dramatic observable changes during the initial encounter period. Mars transforms from humanity's backup world into a subtle trap that appears safe until human colonists begin experiencing health problems that don't match any known terrestrial conditions. The chemical arsenal scenario forces us to confront uncomfortable questions about our readiness for interstellar encounters. If objects like Atlas routinely carry exotic chemistry between star systems, then planetary habitability might be far more vulnerable to disruption than we've assumed. Our entire approach to identifying and preparing backup worlds could be fundamentally flawed if we haven't factored in the possibility of contamination from interstellar sources carrying chemistry that operates by rules we don't understand. Here's what genuinely haunts me about Atlas's chemical signature. The organic compounds we're detecting suggest that interstellar space isn't the sterile void we've imagined. It's actually a complex chemical environment where cosmic radiation creates molecular structures that could never form under planetary conditions. Atlas isn't just carrying frozen water and simple organics, it's potentially delivering a 30,000-year chemistry experiment that we're completely unprepared to analyze or defend against. The carbon dioxide coma that makes Atlas so visually spectacular also makes it the perfect contamination vector. CO2's properties as a solvent mean that any exotic organics dissolved in Atlas's ice will remain chemically active as the coma expands and potentially reaches Mars's atmospheric envelope. We're not just dealing with frozen chemistry that might harmlessly sublimate away. We're potentially dealing with an active chemical delivery system that could deposit alien biochemistry directly into our backup world's environment. What makes this chemical arsenal scenario genuinely nightmarish is the scale mismatch between the threat and our defensive capabilities. If Atlas deposits exotic chemistry on Mars, we have no planetary decontamination systems, no way to reverse chemical contamination on a global scale, no protocols for dealing with biochemistry that doesn't exist in any Earth-based laboratory. Mars could become permanently altered by chemistry we can't understand, can't counteract, and can't predict the long-term effects on human health or terraforming efforts. The rational response is to remember that Mars has survived 4.5 billion years of cosmic bombardment without becoming uninhabitable. The planet shows clear evidence of complex chemistry, water cycles, and even potential microbial life. One comet, regardless of its exotic origins, is unlikely to permanently alter a planet's fundamental chemistry in just a few months. But Atlas isn't arriving at Mars during geological time. It's arriving during human time, at the precise moment when we're transitioning from robotic exploration to permanent settlement. The chemical contamination that Mars could absorb and adapt to over millions of years might be completely incompatible with human colonization timelines measured in decades. We're not asking whether Mars can eventually recover from Atlas's chemistry. We're asking whether the planet will remain suitable for human habitation during the narrow window when our species is ready to establish permanent settlements there. This timing transforms Atlas's chemical arsenal from an academic question about interstellar biochemistry into an immediate threat to humanity's multiplanetary future. Mars colonization requires sustained commitment across multiple decades. If Atlas renders the planet chemically unsuitable for human habitation, even temporarily, it could derail our entire expansion beyond Earth during the critical period when such expansion might determine our species' long-term survival prospects. The timing of Atlas's approach reveals what might be the cruelest cosmic joke ever played on human space exploration. October 3, 2025, places the encounter squarely within the window of solar conjunction, when Mars vanishes behind the Sun from Earth's perspective, like a magician's assistant disappearing behind a curtain of nuclear fire. For several weeks surrounding this date, our backup planet becomes essentially unobservable, hidden behind 1.4 million kilometers of plasma that makes radio communication impossible and optical observation futile. This isn't just an inconvenience, it's a fundamental blindness at the moment when we most desperately need to see. The Mars Reconnaissance Orbiter, MAVEN, the Trace Gas Orbiter, and Mars Express will all continue operating and collecting data, but getting that critical information back to Earth becomes impossible during the conjunction period. It's like having the world's most sophisticated security cameras recording a break-in while the monitoring station is disconnected from the internet and the phone lines are cut. Here's what makes this timing particularly unnerving from a risk assessment perspective. Atlas's erratic behavior suggests it could fragment or experience major outgassing events during its closest approach to the Sun, which occurs in late October at approximately 1.4 astronomical units. The comet has been throwing cosmic tantrums throughout its approach. Sudden brightness increases, followed by mysterious quiet periods that make no sense according to our models of cometary behavior. If Atlas decides to experience its most violent outburst during the conjunction period, we'll miss the entire catastrophe. The mathematics of this visibility gap are genuinely terrifying. Solar conjunction occurs every 26 months, lasting approximately 2 to 3 weeks, depending on the planet's positions. Mars disappears behind the Sun's disk from Earth's perspective, but the communication blackout extends far beyond just the visual obstruction. The Sun's corona creates a radio interference zone that extends millions of kilometers in all directions, turning our most sophisticated deep space communication networks into expensive paperweights. But let's consider the rational counterpoint. NASA and the ESA have been managing Mars missions through dozens of conjunction periods without major incidents. Our Mars-based assets are specifically designed to operate autonomously during these communication blackouts, storing critical data for transmission once windows reopen. The timing might be unfortunate, but it's not unprecedented. We've successfully navigated far more complex mission scenarios with similar communication constraints. Yet this is where Atlas creates genuinely unprecedented challenges that our standard conjunction protocols were never designed to handle. Previous conjunction periods involved predictable mission operations, routine scientific observations, planned equipment maintenance, scheduled system checks. Atlas introduces the possibility of rapid, unpredictable changes to Mars's environment during precisely the period when we can't monitor, assess, or respond to developing situations in real time. Consider this nightmare scenario. Atlas fragments during its late October perihelion passage, creating a debris field of exotic ice and chemistry that spreads across millions of kilometers. Some of this debris reaches Mars during the conjunction period, when we're deaf and blind to everything happening at our backup planet. Our instruments record impacts, atmospheric disturbances, chemical signatures, but we won't receive any of this data until weeks after the encounters are over, when any immediate response opportunities have already passed. The implications of this communication blackout extend far beyond just missing scientific observations. Mars colonization timelines assume we can monitor and protect our backup world continuously during the critical phases of human expansion beyond Earth. If Atlas's encounter demonstrates that we're vulnerable to cosmic threats during predictable communication windows, it fundamentally undermines our confidence in maintaining sustainable contact with Mars colonies during future conjunction periods. Here's what genuinely disturbs me about the visibility catastrophe. It transforms a scientific observation into a test of faith. When Mars emerges from behind the Sun in late November 2025, whatever we see will be our first indication of whether Atlas's passage was routine or transformative. We'll be working backward from effects to causes, trying to reconstruct what happened during those crucial weeks when we couldn't watch our backup worlds encounter with interstellar chemistry. The timing isn't just problematic, it's almost supernaturally cruel. Atlas has been traveling through interstellar space for 30,000 years. Our Mars observation capabilities have existed for less than 3 decades. The probability that this particular interstellar visitor would arrive during our first serious attempts at Mars colonization, precisely during a conjunction period that blinds our most sophisticated surveillance network, seems almost too coincidental to be natural. What if Atlas's timing isn't coincidental? What if objects like this have been testing our solar system's defenses for millennia, and we're only now advanced enough to detect them? The conjunction period represents a predictable vulnerability window that occurs regularly, like a cosmic security guard, who takes the same coffee break every day. Any intelligence capable of interstellar travel would certainly be capable of calculating optimal approach windows that minimize the probability of detection and effective response. Of course, that speculation ventures into territory that would make any respectable astronomer deeply uncomfortable. The much more likely explanation is simple cosmic coincidence. The universe operates according to its own schedules and is under no obligation to arrange our dramatic events around human convenience. Atlas's approach during conjunction is just cosmically bad luck, like a solar eclipse occurring during a crucial astronomical observation. But here's what makes the visibility gap genuinely insidious. It could create false confidence or false panic, depending on what we observe when communication resumes. If Mars appears completely normal when contact resumes, we might conclude that interstellar visitors pose no significant threat to planetary habitability. If we detect atmospheric changes or surface contamination, we might overreact and abandon Mars colonization efforts entirely. Either response could be completely wrong because we're making decisions based on incomplete information gathered during a period when we couldn't directly observe the most critical interactions. The conjunction period also creates perfect conditions for information warfare and conspiracy theories that could undermine public support for Mars colonization, regardless of what actually happens. Social media algorithms optimize for engagement, not accuracy. During the weeks when we can't provide definitive updates about Mars's condition, speculation fills the information vacuum. By the time we can offer factual assessments, public opinion might already be irreversibly shaped by misinformation about Atlas's threat to our backup world. This visibility catastrophe forces us to confront uncomfortable questions about the fundamental assumptions underlying human expansion beyond Earth. We're planning to establish permanent settlements on worlds that periodically become unobservable from our home planet. Are we prepared to make life or death decisions about colonists' safety based on delayed, incomplete information? Mars colonization requires sustained commitment across multiple decades. How do we maintain that commitment when cosmic events routinely demonstrate our inability to monitor and protect our backup world during critical encounters? The rational perspective suggests that conjunction periods are temporary inconveniences that competent space agencies plan around routinely. But Atlas isn't a routine space mission dealing with predictable orbital mechanics and standard operational procedures. It's an unprecedented encounter with chemistry we can't model, arriving at our backup planet during a period when our most sophisticated planetary defense monitoring systems are essentially useless. The cosmic anarchist couldn't have chosen better timing if it had been deliberately planned to test humanity's psychological resilience and technological preparedness for multi-planetary civilization. Atlas is arriving during the narrow window, when we're advanced enough to detect interstellar threats, but not yet robust enough to observe them continuously. We're cosmic adolescents encountering adult challenges, and the visibility gap ensures we'll be learning about the results of this encounter long after our opportunity to influence the outcome has passed. Mars presents a uniquely vulnerable target for Atlas's approach, and understanding this vulnerability requires confronting some genuinely uncomfortable truths about our backup planet's complete lack of natural defenses. Unlike Earth, which enjoys the protection of a robust magnetic field that deflects charged particles and cosmic radiation, Mars lost its magnetosphere billions of years ago. The red planet essentially stands naked before the cosmos, protected only by an atmosphere so pathetically thin it barely qualifies as atmospheric at all. This defensive vulnerability becomes critically important when we consider Atlas's potential contamination mechanisms. The traditional Hollywood collision scenario, massive impact, global devastation, planetary sterilization, focuses our attention on kinetic energy transfer. But Atlas's true threat potential lies in something far more subtle and potentially more dangerous: its capacity to deliver exotic chemistry to a world that has virtually no natural filtering or protective systems to prevent atmospheric contamination. Here's what keeps me awake when I'm studying atmospheric protection models. Mars's atmosphere has a surface pressure roughly equivalent to what you'd experience at 100,000 feet altitude above Earth. It's not just thin, It's practically non-existent by any meaningful standard of atmospheric protection. When Atlas's massive carbon dioxide coma expands across millions of kilometers of space, even at 30 million kilometers distance, the outer edges of that exotic chemistry cloud could theoretically interact with Mars's atmospheric envelope. The mathematics of atmospheric vulnerability are genuinely terrifying. Earth's dense atmosphere burns up meteoric debris, filters cosmic radiation, and provides multiple layers of chemical and physical protection against contamination from space. Mars offers none of these defenses. The planet's atmospheric density is so low that even small particles can reach the surface with minimal heating or chemical alteration. Any exotic chemistry that Atlas delivers will arrive at Mars essentially intact, ready to interact with surface minerals and atmospheric compounds in ways we can't predict or control. But let's examine the rational perspective on Mars's atmospheric vulnerability. The planet has survived 4.5 billion years of cosmic bombardment without becoming completely sterile. Mars has been exposed to solar radiation, asteroid impacts, cometary encounters, and interstellar cosmic rays throughout its entire geological history. The planet shows clear evidence of complex chemistry, water cycles, and potentially even microbial life. Mars's thin atmosphere might provide minimal protection, but it also means that any contamination would be rapidly diluted and dispersed across the planet's surface. Yet this is where Mars's unique surface chemistry creates genuinely disturbing possibilities for Atlas's encounter. The planet is loaded with perchlorates, highly reactive chemical compounds that exist in concentrations that would be immediately lethal to most Earth-based life forms. These perchlorates aren't just passive contaminants. They're chemical catalysts that could accelerate interactions between Mars's existing chemistry and any exotic organics that Atlas might deliver. Mars isn't just vulnerable to contamination, it's essentially primed for explosive chemical reactions between alien biochemistry and highly reactive surface compounds. Any exotic chemistry that survives the journey from Atlas's coma to Mars's surface could find itself in an environment that either destroys it completely through violent chemical reactions or catalyzes it in ways that create entirely new, potentially dangerous compounds we've never observed. The timing of Atlas's approach amplifies these vulnerability concerns exponentially. Late October places Atlas at perihelion, its closest approach to the Sun, just weeks after the Mars encounter. This means Atlas will be at peak activity, maximum outgassing, highest probability of fragmentation during the period when our observation capabilities are most compromised by solar conjunction. Mars's defensive vulnerability combines with our observational blindness to create a perfect storm of uncertainty about what's actually happening to our backup world. Consider this unsettling scenario. Atlas fragments during perihelion, creating a debris field of exotic ice and chemistry that continues along its trajectory. Some of this debris reaches Mars months later, during a period when we've resumed normal observations but aren't expecting further encounters. Mars's lack of early warning systems, no magnetic field to deflect incoming objects, no dense atmosphere to create visible meteor trails, means the planet could be receiving continued contamination from Atlas long after we've declared the initial encounter concluded. Here's what makes Mars's nakedness particularly disturbing. We're planning to send human colonists to a world that can't protect itself from cosmic threats we're only beginning to understand. Earth's magnetic field and dense atmosphere provide multiple layers of protection that we take for granted. Mars offers none of these natural defenses. Every human settlement we establish there will be completely dependent on artificial life support systems and technological protection against cosmic hazards. The naked planet scenario forces us to confront whether our Mars colonization plans adequately account for the planet's fundamental vulnerability to contamination from interstellar sources. We've been designing habitats and life support systems assuming that Mars's main environmental challenges are low atmospheric pressure, temperature extremes, and radiation exposure from our own sun. Atlas suggests we need to factor in the possibility of chemical contamination from sources carrying exotic chemistry that could interact with Mars's surface in ways that make the planet permanently unsuitable for human habitation. Still, a skeptic would rightfully point out that Mars's surface shows no evidence of exotic contamination or alien biochemistry from previous interstellar encounters. The planet has been exposed to cosmic chemistry for billions of years through cosmic ray interactions and occasional interstellar dust particles. If exotic interstellar biochemistry were inherently dangerous to planetary environments, we'd expect to see clear geological evidence of contamination or sterilization in Mars's rock record. But this rational perspective misses the critical difference between geological time and human time. Previous interstellar encounters occurred over timescales that allowed Mars's systems to gradually adapt and stabilize. Any chemical contamination was diluted across millions of years, giving the planet's chemistry time to reach new equilibrium states. Atlas is arriving during human time, at the precise moment when we're transitioning from robotic exploration to permanent settlement of a world that might not remain chemically stable during the decades required for successful colonization. The naked planet forces us to ask uncomfortable questions about humanity's readiness for multiplanetary civilization. Are we prepared to establish permanent settlements on worlds that lack the natural protective systems that made life on Earth possible? Our entire biological evolution occurred under the protection of Earth's magnetic field and dense atmosphere. Mars colonization requires us to survive and reproduce in an environment that offers none of these fundamental protections against cosmic hazards. Here's what genuinely terrifies me about Mars's vulnerability. The planet's lack of natural defenses means that any contamination event, whether from Atlas or future interstellar visitors, could have permanent consequences for human habitability. Earth's protective systems allow our planet to recover from cosmic impacts and chemical contamination over geological time. Mars lacks these recovery mechanisms. Any damage Atlas inflicts on our backup world's habitability could persist for the entire duration of human civilization's expansion beyond Earth. The cosmic anarchist has chosen to test humanity's multiplanetary ambitions by approaching the most vulnerable planet in our solar system at the precise moment when we're most committed to making it our second home. Mars's naked exposure to cosmic threats isn't just an interesting geological detail, it's potentially the fatal flaw that transforms our species' backup plan into an elaborate cosmic trap. When I examine Atlas's behavioral profile through the lens of structural mechanics and thermal stress analysis, what I see is an object under extreme internal pressure that's rapidly approaching its breaking point. Those unpredictable brightness surges aren't just pretty light shows, they're the visible signatures of an object literally tearing itself, apart from the inside. 30,000 years of interstellar radiation bombardment doesn't just freeze a comet. It fundamentally alters its internal structure, creating pockets of exotic ice with wildly different sublimation temperatures and structural properties. Here's what makes my hands shake when I'm reviewing trajectory calculations. Cometary fragmentation isn't a gentle, predictable process that happens gradually over months or years. When objects like Atlas finally reach their structural failure point, they don't politely disassemble into manageable pieces. They explode with kinetic energies equivalent to multiple nuclear weapons simultaneously detonating in space, creating debris fields that spread across millions of kilometers at velocities that make tracking and prediction nearly impossible. The mathematics of potential Atlas fragmentation are genuinely apocalyptic. Even relatively small fragments, chunks of exotic ice measuring 100 to 500 meters in diameter, carry devastating kinetic energy when moving at interstellar velocities. Mars's thin atmosphere provides virtually no protection against such impacts. Unlike Earth, where our dense atmospheric envelope burns up most meteoric debris before it can reach the surface, Mars would take these hits directly, potentially vaporizing exotic chemistry across vast areas of the planet's surface. The timing of potential fragmentation creates a scenario that reads like cosmic horror fiction. Atlas reaches its closest approach to the Sun in late October, approximately 3 weeks after its Mars encounter. This perihelion passage represents the moment of maximum thermal stress, when the comet's exotic internal structure will be subjected to heating patterns it has never experienced during its 30,000-year journey through the frozen void between stars. If Atlas is going to come apart, perihelion is when it will happen. But let's step back and examine the rational assessment of fragmentation risks. Most comets that experience structural failure do so much closer to the Sun than Atlas's projected perihelion at 1.4 astronomical units. The majority of documented cometary breakup events occur inside the orbit of Mars, not outside it. Atlas's distance from the Sun during its closest approach suggests it will experience significant heating and outgassing, but probably not enough thermal stress to cause catastrophic structural failure. Yet this is where Atlas's interstellar origin creates genuinely unprecedented concerns that make standard cometary behavior models potentially useless. We have no baseline for understanding how objects exposed to 30,000 years of cosmic radiation behave under solar heating. The exotic ice compositions that create those erratic brightness surges could have wildly different thermal expansion coefficients, sublimation points, and structural properties than anything in our solar system's standard comet catalogue. Here's the nightmare scenario that keeps me staring at orbital mechanics simulations. Atlas experiences a major fragmentation event during the solar conjunction period, precisely when we can't observe Mars directly. The explosion creates thousands of fragments ranging from dust particles to city-sized chunks of exotic ice, all following slightly different trajectories toward various points in our solar system. Some of these fragments continue toward Mars over the following weeks and months, creating an extended bombardment period that we can't predict or track effectively. Consider the implications for Mars's habitability if fragmentation occurs. Each impact of exotic ice would instantly vaporize alien chemistry directly into Mars's thin atmosphere, creating chemical interactions that we can't model or predict. Unlike single-point contamination that might remain localized, multiple fragment impacts would distribute Atlas's exotic chemistry across the entire planet within months as Mars's global dust storms and atmospheric circulation patterns spread the contamination worldwide. The debris field scenario becomes even more horrifying when we factor in Phobos, Mars's largest moon, which orbits just 6,000 kilometers above the planet's surface. Phobos is already in a slowly decaying orbit that will eventually cause it to crash into Mars in about 50 million years, under normal circumstances. But if Atlas's debris field includes fragments large enough to perturb Phobos's orbital mechanics, we could witness the accelerated destruction of Mars's moon during our observation lifetime. The implications of rapid Phobos destruction are genuinely apocalyptic for Mars colonization efforts. When Phobos disintegrates, whether naturally over millions of years or artificially accelerated by Atlas fragment impacts, it won't create stable, pretty rings like Saturn's. Mars lacks the complex gravitational dynamics necessary to maintain organized ring systems. Instead, Phobos's destruction would create a chaotic debris field in low Mars orbit, essentially turning the space around our backup planet into a cosmic shooting gallery that would make spacecraft operations extremely hazardous for centuries. Still, the conservative perspective reminds us that fragmentation events, while spectacular, are relatively rare even among comets that approach much closer to the Sun than Atlas's projected perihelion. Most comets survive their solar encounters intact, experiencing outgassing and tail development without catastrophic structural failure. Atlas might be exotic in composition, but it's still bound by the same physical laws that govern all matter in our universe. But here's what makes the fragmentation protocol genuinely insidious. We won't know whether Atlas has fragmented until long after any debris reaches Mars. The solar conjunction period that conceals the Mars encounter also conceals the critical perihelion passage when fragmentation would most likely occur. We'll be trying to reconstruct what happened by analyzing impact, craters and atmospheric changes weeks or months after fragments have already reached our backup planet. The fragmentation scenario forces us to confront the most disturbing aspect of Atlas's encounter: our complete inability to predict or defend against the consequences if things go wrong. If Atlas fragments during perihelion and some debris reaches Mars, we have no planetary defense systems capable of intercepting exotic ice chunks traveling at interstellar velocities. We have no protocols for dealing with multiple impact events scattered across months or years. We have no technology for reversing chemical contamination on a planetary scale. Here's what genuinely haunts me about the fragmentation possibility. The timescales involved could perfectly coincide with humanity's most ambitious Mars colonization efforts. We're planning to establish permanent human presence on Mars within the next 2 decades. If Atlas fragments and creates an extended debris bombardment of our backup planet, our colonists could arrive to find themselves living on a world under intermittent attack from exotic chemistry we can't predict or defend against. The rational response is to remember that Mars has survived billions of years of cosmic bombardment without becoming uninhabitable. The planet shows clear evidence of water, complex chemistry, and potentially even microbial life. One fragmenting comet, even an exotic one, is unlikely to permanently sterilize a world that has already demonstrated remarkable resilience to cosmic catastrophes. But Atlas represents more than just another cosmic impact event. It's potentially the first large-scale contamination of Mars by interstellar chemistry during the critical period when human civilization is transitioning from single planet to multi-planetary existence. The chemical contamination that Mars could absorb and adapt to over millions of years might be completely incompatible with human colonization timelines measured in decades, rather than geological epochs. The fragmentation protocol transforms Atlas from an interesting astronomical object into an immediate threat to humanity's multiplanetary future. If the comet comes apart and showers Mars with exotic debris, we could witness real-time transformation of our backup world from a future human habitat into a contaminated wasteland during the narrow historical window when such contamination would most compromise our species' expansion beyond Earth. The spectroscopic signatures emerging from Atlas's coma reveal what can only be described as a 30,000-year chemistry experiment conducted in the radiation laboratory of interstellar space, and the preliminary results should terrify anyone who's been planning to breathe Martian air or grow food in Martian soil. When NASA's most sophisticated instruments analyze the organic compounds sublimating from Atlas's nucleus, we're not looking at familiar biochemistry or even typical solar system organics. We're staring at molecular structures that were literally forged in the cosmic radiation environment between stars, creating chemistry that has never existed anywhere in our local stellar neighborhood. This is what keeps my pulse racing when I examine the data streams from the James Webb Space Telescope. Carbon dioxide at the specific temperatures and pressures Atlas is generating doesn't just create pretty visual displays. CO2 becomes an extraordinarily effective solvent for organic compounds, arguably superior to water for dissolving and transporting complex molecular structures, particularly in the low-pressure environments that characterize planetary atmospheres like Mars's. Atlas's massive carbon dioxide coma isn't just astronomically impressive, it's potentially the perfect delivery mechanism for whatever exotic biochemistry this interstellar wanderer accumulated during its millennia-long journey through the radiation-soaked void between star systems. The European Space Agency's preliminary spectral analysis reveals organic signatures that don't just differ from our databases. They represent entirely novel molecular architectures that suggest chemical processes we've never observed anywhere in our solar system. These aren't variations on familiar themes of carbon-hydrogen chains or simple amino acids. They're completely alien symphonies composed in the cosmic radiation environment of deep space, where stellar winds and high-energy particles create chemical reactions that are literally impossible under planetary conditions. What makes this chemistry particularly insidious is its potential interaction with Mars's unique surface environment. The red planet is essentially a giant chemistry lab loaded with perchlorates, highly reactive chemical compounds that exist in concentrations lethal to most Earth-based life forms. But perchlorates aren't just passive contaminants sitting in Martian soil. They're chemical catalysts that could accelerate interactions between Mars's existing mineral chemistry and any exotic organics that Atlas delivers to the planet's surface. Here's where the scenario becomes genuinely nightmarish. Mars isn't just vulnerable to contamination from Atlas's chemistry set. The planet is actively primed for explosive chemical reactions between alien biochemistry and highly reactive surface compounds that have been accumulating for billions of years. Any exotic chemistry that survives the journey from Atlas's coma to Mars's surface could find itself in an environment that either destroys it completely through violent oxidation reactions or catalyzes it in ways that create entirely new, potentially lethal compounds we've never studied in any terrestrial laboratory. Yet let's examine the rational perspective before we spiral into complete panic. Organic chemistry operates according to universal physical laws, regardless of where it originates. Carbon, hydrogen, oxygen, and nitrogen behave according to the same quantum mechanical principles, whether they're on Earth, Mars, or floating in the radiation environment of interstellar space. Complex organic molecules are actually quite common throughout the universe. We routinely detect them in meteorites, interstellar dust clouds, planetary atmospheres, and even in the chemical signatures of distant exoplanets. But this is where Atlas's 30,000-year exposure to interstellar radiation creates genuinely unprecedented concerns that standard organic chemistry models can't address. The exotic compounds we're detecting in Atlas's coma show isotope ratios and molecular structures that suggest exposure to radiation environments we've never been able to replicate in laboratory conditions. We're not just dealing with familiar chemistry that happened to form in space. We're potentially confronting biochemistry that was literally cooked by cosmic radiation in ways that could create properties we can't predict or control. The timing of Atlas's chemistry delivery makes this contamination scenario particularly devious. The solar conjunction period means we'll miss the initial chemical interactions between Atlas's exotic organics and Mars's reactive surface environment entirely. When Mars emerges from behind the Sun in late November, any alien chemistry that Atlas deposited will have had weeks to interact with Martian perchlorates, atmospheric compounds, and mineral compositions. We'll be analyzing the results of chemical reactions rather than observing the reactions themselves, like walking into a laboratory hours after an explosion and trying to reconstruct what chemicals were mixed together by examining the remaining residue. What genuinely terrifies me about this chemistry scenario is the global distribution potential. Mars's thin atmosphere and notorious dust storms mean that any contamination reaching the planet's surface would spread worldwide within months. Unlike Earth, where weather patterns and geographical barriers might contain chemical contamination to specific regions, Mars's atmospheric dynamics would distribute Atlas's exotic chemistry across every future landing site, every planned colony location, every terraforming experiment we're hoping to conduct over the next century. Consider this particularly disturbing timeline. Atlas's chemistry reaches Mars and begins interacting with surface perchlorates during the conjunction period when we can't observe the reactions. These interactions don't create immediately obvious toxic effects that our instruments could easily detect. Instead, they produce subtle chemical changes that gradually alter Mars's atmospheric and soil chemistry over months and years. By the time human colonists arrive in the 2030s, Mars has become biologically incompatible with human physiology in ways so complex and gradual that we don't recognize the threat until settlers begin experiencing neurological symptoms, respiratory problems, or reproductive failures that don't match any known terrestrial medical conditions. The chemistry set from hell scenario forces us to confront whether our Mars colonization plans adequately account for the possibility of chemical contamination from interstellar sources carrying biochemistry that operates by rules we don't understand. We've been designing life support systems and terraforming technologies assuming that Mars's main chemical challenges involve known compounds, perchlorates, carbon dioxide, trace atmospheric gases, familiar mineral compositions. Atlas suggests we need to factor in the possibility of exotic chemistry that could interact with Mars's environment to create entirely new categories of hazards. Still, skeptics rightfully point out that Mars has been exposed to interstellar chemistry for billions of years through cosmic ray interactions, interstellar dust particles, and previous cometary encounters. If exotic interstellar biochemistry posed fundamental threats to planetary habitability, we'd expect to see clear evidence of contamination or sterilization in Mars's geological record. The planet shows no signs of being chemically compromised by previous encounters with alien chemistry. Nevertheless, this rational assessment misses the critical difference between geological exposure and concentrated delivery. Previous interstellar contamination occurred through individual cosmic ray interactions and microscopic dust particles spread across millions of years. Atlas represents a massive, concentrated dose of interstellar chemistry delivered to Mars during the specific historical window when human civilization is actively planning permanent settlement. We're not studying academic questions about planetary chemistry over geological time. We're potentially witnessing real-time contamination of humanity's backup world during the narrow period when such contamination would most severely compromise our species' expansion beyond Earth. Here's what makes Atlas's chemistry set truly insidious. The exotic compounds could create delayed action toxicity that doesn't manifest until months or years after initial exposure. Mars colonists might arrive to find atmospheric processes and soil cultivation systems working perfectly according to all pre-Atlas specifications. Agricultural systems might produce crops that appear healthy and nutritious. Life support systems might maintain comfortable habitat conditions without any obvious problems. But gradually, colonists could begin experiencing health effects from exotic chemistry interactions that we couldn't predict, couldn't test for, and can't treat with medical knowledge based entirely on terrestrial biochemistry. The chemistry set from hell transforms Atlas from an interesting astronomical object into an existential threat to human expansion beyond Earth. If this interstellar visitor deposits exotic chemistry that makes Mars permanently unsuitable for human habitation, or even temporarily unsuitable during the critical decades when our species is ready to establish permanent settlements, it could force humanity to abandon our most advanced plans for multi-planetary civilization and retreat to Earth indefinitely while we develop new planetary defense technologies or identify alternative backup worlds. What haunts me about Atlas's chemistry is the possibility that interstellar biochemistry represents a routine hazard that we've never had to consider because our species has never before attempted to establish permanent settlements on worlds beyond Earth's protective magnetosphere and dense atmosphere. Every previous human expansion into new environments occurred within Earth's natural protective systems. Mars colonization requires us to survive and reproduce in an environment completely exposed to cosmic chemistry that could arrive without warning and operate according to rules we're only beginning to understand. The gravitational mathematics surrounding Atlas's encounter with Mars reveal cascading possibilities that extend far beyond the immediate October 3rd approach, and what I'm seeing in the long-term orbital propagation models genuinely makes me question whether we're witnessing a single astronomical event or the opening move in a decades-long gravitational chess game that could reshape the dynamics of our entire inner solar system. When massive objects interact gravitationally in space, they don't simply affect each other and then continue on their merry way. They alter orbital mechanics throughout the entire local gravitational environment in ways that compound exponentially over years and decades. What makes my stomach drop when I'm running these trajectory calculations is this. Atlas isn't just approaching Mars and then disappearing back into interstellar space like some cosmic tourist taking a quick photograph. The encounter will fundamentally alter Atlas's velocity vector and trajectory through gravitational interactions with Mars, potentially sending the comet on an entirely new path through our solar system. Even tiny changes in Atlas's speed or direction during the Mars flyby, modifications measured in meters per second, could result in dramatically different orbital characteristics that bring this interstellar visitor back for additional encounters with inner solar system objects over the following decades. The nightmare scenario unfolds through the relentless mathematics of orbital mechanics. Atlas's gravitational interaction with Mars changes its trajectory just enough to establish a bound orbit around our Sun, instead of the expected hyperbolic escape trajectory that should carry it back to interstellar space. We're not talking about immediate catastrophe. We're talking about Atlas becoming a permanent resident of our solar system, a rogue gravitational influence that periodically threatens every planet in our neighborhood, including Earth itself, for the entire duration of human civilization's expansion beyond our home world. Here's where the timing becomes cosmically cruel. Atlas's potential orbital capture occurs precisely during the historical period when humanity is establishing permanent settlements on multiple worlds. If Atlas begins making regular appearances in our inner solar system every few decades, it transforms from a single encounter we can study and prepare for into an ongoing existential threat that must be factored into every interplanetary mission, every colonial supply run, every communication network, and every long-term, terraforming project we attempt over the next several centuries. Yet let's step back and examine the rational assessment of orbital capture probabilities. Cometary trajectories, particularly for objects approaching from interstellar space, are generally hyperbolic by definition. They approach the Sun, swing around our star in a single gravitational interaction, and then head back toward interstellar space with sufficient velocity to escape our solar system permanently. The probability of Atlas being gravitationally captured into a bound solar orbit is extremely low according to standard celestial mechanics calculations. But this is where the three-body gravitational problem creates genuinely disturbing possibilities that linear calculations can't fully capture. Mars isn't the only gravitational player in Atlas's encounter scenario. Jupiter's massive influence, the Sun's overwhelming gravitational field, and even Earth's orbital position all contribute to the complex dynamics that will determine Atlas's final trajectory. The encounter with Mars represents just one variable in a chaotic gravitational system that could produce completely unexpected results through subtle interactions between multiple massive objects. Consider this unsettling detail that emerges from the orbital mathematics. Atlas has been accumulating kinetic energy for 30,000 years during its journey from another star system. When that enormous energy reservoir interacts with Mars's gravity field, the resulting trajectory modifications don't just affect Atlas's immediate path. They create gravitational ripples throughout the dynamics of our entire inner solar system that we won't fully understand until we can observe the consequences over multiple orbital periods. The cascade effect becomes even more terrifying when we factor in the possibility of Atlas fragmenting during its perihelion passage in late October. If the comet breaks apart into multiple large fragments, each piece follows a slightly different trajectory through our solar system. Instead of dealing with one potentially dangerous object on a predictable orbit, we could find ourselves trying to track and predict the paths of dozens of Atlas fragments, each carrying enough kinetic energy to pose existential threats to planetary habitability if they happen to encounter worlds during future orbital periods. Here's the scenario that genuinely haunts me. Atlas's encounter with Mars creates orbital perturbations that aren't immediately obvious or threatening. The comet continues toward perihelion as expected, but its modified trajectory includes periodic returns to the inner solar system every 30 to 50 years. 2 or 3 decades later, when humanity has established thriving colonies on Mars and lunar bases around Earth, Atlas returns for its second act, this time on a trajectory that brings it much closer to Earth during a period when our home world is completely dependent on interplanetary supply chains and communication networks. The implications for long-term space exploration are staggering in their scope and complexity. If Atlas becomes a recurring threat to Earth-Mars trajectories, it fundamentally alters the economic and safety calculations underlying our entire multiplanetary civilization project. Cargo ships carrying essential supplies between worlds would need to factor in unpredictable appearances of a massive object with unknown fragmentation potential. Passenger vessels would require radiation shielding and life support systems capable of handling extended detours around Atlas's debris field. Communication satellites and navigation networks would need backup systems to maintain interplanetary coordination when Atlas's gravitational influence disrupts standard orbital mechanics. Still, the conservative perspective reminds us that our solar system has remained gravitationally stable for 4.5 billion years, despite countless encounters with comets, asteroids, and other massive objects. The fundamental orbital mechanics that govern planetary motion have proven remarkably resilient to disruption. Atlas, regardless of its exotic origins and impressive mass, represents just one additional object in a system that has successfully integrated millions of such objects without losing its basic stability. Nevertheless, this rational assessment misses the critical difference between geological stability and human timescale predictability. Previous gravitational disruptions occurred over millions of years, allowing planetary orbits and asteroid trajectories to gradually settle into new, stable configurations. Human civilization operates on much shorter timescales. We need orbital predictability measured in decades, not millennia. If Atlas creates even minor perturbations in inner solar system dynamics, it could render our current interplanetary navigation and mission planning systems obsolete just when we most need reliable access to other worlds. What makes the orbital mechanics scenario particularly insidious is our complete inability to predict or control the long-term consequences of Atlas's gravitational interactions. Unlike chemical contamination that we might theoretically be able to detect and respond to, orbital mechanics operate according to mathematical laws that unfold inevitably over time. If Atlas's encounter with Mars establishes orbital characteristics that bring it back to threaten Earth or other human settlements in future decades, we have no technology capable of altering the trajectory of an object that massive traveling at interstellar velocities. The orbital mechanics of doom force us to confront whether human expansion beyond Earth adequately accounts for the possibility of long-term gravitational threats from interstellar visitors. We've been planning multiplanetary civilization, assuming that the basic orbital dynamics of our solar system will remain stable and predictable throughout the centuries required for successful interplanetary expansion. Atlas suggests we might need to develop space-based defense systems capable of detecting and deflecting massive objects decades before they pose immediate threats to human settlements. Here's what genuinely terrifies me about the gravitational cascade scenario. The timeline for Atlas's potential return visits could coincide perfectly with humanity's most vulnerable expansion phases. We're planning to establish permanent settlements throughout the solar system over the next century. If Atlas begins making regular appearances that disrupt interplanetary transportation and communication, our colonies could find themselves isolated from each other and from Earth during the critical decades when they most need sustained support to achieve self-sufficiency. The cosmic anarchist isn't just testing our immediate preparedness for interstellar encounters, it's potentially establishing orbital mechanics that will test human civilization's resilience for centuries to come. Atlas could transform from a single astronomical event we study and learn from into a permanent feature of our solar system that forces every future generation to factor interstellar threats into their most basic survival planning. The solar conjunction period that conceals Atlas's encounter with Mars represents more than just an inconvenient communication blackout. It's potentially the first test of whether human civilization can maintain psychological and political stability when we lose contact with our backup world during an existential crisis. What genuinely terrifies me about this communication apocalypse isn't the technical challenge of managing Mars missions without real-time Earth contact, but the information warfare and social chaos that could erupt on Earth when we can't provide definitive updates about what's happening to the planet we've promised will secure humanity's multiplanetary future. This is what keeps me awake, studying the sociology of information crises. We're living through a historical period when public trust in scientific institutions oscillates wildly between blind faith and paranoid skepticism, when social media algorithms optimize for engagement rather than accuracy, and when geopolitical tensions create perfect conditions for adversaries to exploit information vulnerabilities during national emergencies. Atlas's approach during the conjunction period creates an information vacuum that hostile actors could fill with manufactured crises designed to undermine confidence in space exploration programs worth hundreds of billions of dollars. The timeline of this communication catastrophe unfolds with cruel precision. Atlas approaches Mars in early October, while our most authoritative information sources, the Mars Reconnaissance Orbiter, MAVEN, Perseverance rover, and our entire interplanetary communication network, fall silent for weeks due to solar interference. In the absence of official data streams, speculation fills the information ecosystem. Social media platforms become breeding grounds for conspiracy theories about what's really happening to Mars during the blackout period. By the time communication resumes in late November, public perception of Mars colonization could be permanently altered, regardless of what actually occurred during Atlas's encounter. Here's what makes this information crisis particularly dangerous. The stakes involved in Mars colonization decisions extend far beyond academic curiosity about cometary encounters. We're talking about policy choices that will determine the allocation of hundreds of billions of dollars, the careers of thousands of aerospace professionals, and potentially the long-term survival prospects of human civilization. The information war surrounding Atlas isn't just about scientific accuracy. It's about the future of humanity's expansion beyond Earth during the narrow historical window, when such expansion might be technologically and economically feasible. Consider this nightmare scenario for space policy. Atlas approaches Mars exactly as predicted, a routine astronomical event with no significant impact on planetary habitability or colonization planning. But the information vacuum during conjunction allows misinformation campaigns to spread globally, claiming that Mars has been contaminated by alien chemistry, that our backup planet is no longer suitable for human habitation, that space agencies are covering up catastrophic damage to protect their budgets and reputations. By the time we can provide factual data showing Mars is completely unaffected, political leaders responding to constituent pressure have already begun questioning the wisdom of investing in Mars colonization when our backup world appears vulnerable to unpredictable cosmic threats. The implications of this information warfare scenario are genuinely apocalyptic for humanity's multiplanetary future. Mars colonization requires sustained political and economic commitment across multiple decades and multiple electoral cycles. If Atlas's encounter creates public perception that Mars is fundamentally unsafe for human settlement, regardless of the scientific reality, the entire project could lose the political support necessary for long-term success. One interstellar comet could end humanity's best hope for becoming a spacefaring civilization, not through direct physical damage to Mars, but through information warfare that destroys public confidence in our backup planet's viability. Yet let's examine the rational perspective on information management during crisis periods. NASA and the ESA have decades of experience communicating complex astronomical events to global audiences. Their communication protocols emphasize scientific uncertainty, evidence-based assessment, and careful distinction between observation and speculation. The space agencies have successfully managed public communication around dozens of potentially hazardous objects, solar storms, equipment failures, and mission emergencies without creating widespread panic or undermining long-term program support. But Atlas creates genuinely unprecedented challenges for science communication that our standard public information protocols were never designed to handle. Previous space emergencies involved predictable technical problems with known solutions and established response procedures. Atlas introduces the possibility of rapid, unpredictable changes to planetary environments using exotic chemistry that we can't model or explain to public audiences in accessible terms. The conjunction period means our most credible information sources will be silent precisely when public demand for authoritative updates reaches maximum intensity. This is where the information apocalypse becomes truly insidious. Foreign adversaries or domestic political actors could deliberately amplify misinformation about Atlas's threat potential to undermine confidence in American and European space exploration capabilities. The conjunction period's information vacuum creates perfect conditions for manufactured crises that serve geopolitical objectives completely unrelated to actual astronomical events. False reports of Mars atmospheric contamination, fabricated leaked communications from space agencies, or deepfake videos showing catastrophic surface impacts could spread globally through social media platforms before authoritative sources can respond with factual corrections. What makes this scenario particularly devious is the asymmetric nature of information warfare during crisis periods. Creating convincing misinformation requires relatively modest resources and technical capabilities that are accessible to state actors, terrorist organizations, or even sophisticated individual hackers. Debunking misinformation requires extensive scientific analysis, peer review processes, and coordinated responses from multiple authoritative institutions, processes that take weeks or months to complete properly. During Atlas's conjunction period, misinformation could achieve global distribution and political impact long before accurate information becomes available. The communication apocalypse forces us to confront uncomfortable questions about the information infrastructure underlying human expansion beyond Earth. We're planning to establish permanent settlements on worlds that periodically become uncommunicable from our home planet due to predictable astronomical events. Are we prepared to maintain public and political support for multiplanetary civilization when cosmic encounters routinely demonstrate our inability to monitor and protect our backup worlds during critical periods? Here's what genuinely haunts me about the information warfare scenario. Even completely benign Atlas encounter could create lasting damage to humanity's space exploration programs if hostile actors successfully exploit the conjunction period to spread misinformation about Mars's habitability. The scientific reality of what happens to our backup planet during Atlas's approach matters less than public perception of what happened. If adversaries convince significant portions of the global population that Mars has been compromised by alien contamination, the resulting political backlash could delay human expansion beyond Earth by decades while we develop new planetary defense technologies or identify alternative backup worlds. Still, the optimistic perspective suggests that our information ecosystems have developed sophisticated fact-checking mechanisms and that scientific literacy has improved significantly over recent decades. The global space community includes thousands of independent observers, amateur astronomers, university researchers, and citizen scientists who can provide verification and context for official agency communications. Misinformation about major astronomical events typically gets corrected relatively quickly by the distributed network of space enthusiasts and professional researchers. Nevertheless, this technological optimism underestimates the speed and scale at which misinformation can spread through social media platforms during crisis periods. Atlas's conjunction blackout could last several weeks, more than enough time for carefully crafted misinformation campaigns to achieve permanent political damage to space exploration programs, even if the false information is eventually corrected by scientific authorities. The communication apocalypse transforms Atlas from an interesting astronomical event into a test of whether democratic societies can maintain rational policy-making about existential risks when faced with information warfare designed to exploit our deepest fears about cosmic vulnerability. The interstellar visitor isn't just approaching Mars, it's approaching the fragile information infrastructure that supports public confidence in humanity's multi-planetary future. What terrifies me most about this scenario is the possibility that Atlas's real threat to human civilization isn't exotic chemistry or gravitational perturbations. It's the demonstration that our species isn't psychologically prepared for the information challenges that come with expanding beyond Earth. If we can't maintain rational discourse about space exploration during a few weeks of communication blackout, how will we handle the decades-long isolation periods that interplanetary colonies will inevitably experience during their development towards self-sufficiency? The long-term implications of Atlas's encounter with Mars extend far beyond immediate contamination concerns into the realm of terraforming technologies that represent humanity's most ambitious plans for transforming our backup planet into a genuine second Earth. What genuinely terrifies me when I examine the potential interaction between Atlas's exotic chemistry and our planned atmospheric engineering systems is this. We could witness the real-time sabotage of technologies that took decades to develop and deploy, rendering Mars permanently resistant to the terraforming processes that were supposed to make it habitable for large-scale human civilization. This is what makes my hands shake when I review atmospheric processor specifications. Our entire approach to Mars terraforming assumes we understand the planet's basic atmospheric and surface chemistry well enough to predict how artificial greenhouse gases, atmospheric seeding, and chemical processing systems will behave over the centuries required for successful planetary engineering. Atlas introduces exotic chemistry variables that could interfere with atmospheric processes in ways that make our most sophisticated terraforming technologies not just ineffective, but actively counterproductive. The European Space Agency's preliminary models for Mars atmospheric engineering depend critically on predictable chemical reactions between artificially introduced greenhouse gases and the planet's existing atmospheric composition. These systems are designed to gradually thicken Mars's atmosphere, raise surface temperatures, and potentially even re-establish liquid water cycles across significant portions of the planet's surface. But if Atlas deposits exotic chemistry that interferes with greenhouse gas molecules or creates unexpected chemical pathways that neutralize our atmospheric engineering efforts, Mars could become permanently resistant to terraforming regardless of how much time and resources we invest in planetary modification technologies. Here's where the scenario becomes genuinely nightmarish from a planetary engineering perspective. Atlas's exotic organic compounds could interact with our planned atmospheric processes to create chemical byproducts that are toxic to the very life forms we're hoping to establish on Mars, instead of gradually transforming Mars into a more Earth-like world suitable for human habitation. Our terraforming efforts could inadvertently create atmospheric conditions that are lethal to terrestrial biology, while remaining unsuitable for any indigenous Martian life that might currently exist in subsurface environments. The timing of Atlas's encounter makes this terraforming sabotage scenario particularly cruel. We're currently in the advanced planning and early deployment phases for Mars atmospheric modification technologies. The first experimental atmospheric processors are scheduled for deployment within the next decade, with major terraforming operations beginning in the 2040s and 2050s. If Atlas fundamentally alters Mars's atmospheric or surface chemistry during this critical preparation period, we could discover that our entire terraforming technology suite has become obsolete before we've had a chance to test it under real Martian conditions. But let's examine the rational counter-argument about terraforming resilience. Atmospheric engineering technologies are specifically designed to handle unpredictable chemical variations and unexpected interactions between artificial and natural atmospheric systems. Mars terraforming requires robust, adaptable technologies capable of functioning despite incomplete knowledge of planetary chemistry. Our atmospheric processors include extensive monitoring systems, automatic adjustment capabilities, and backup protocols designed to handle chemical surprises that we can't anticipate during the planning phase. Yet this is where Atlas's interstellar origin creates genuinely unprecedented challenges that our terraforming redundancy systems were never designed to address. We can plan for variations in known Martian chemistry, unexpected interactions between familiar atmospheric compounds, or even contamination from Earth-based organic materials that might be accidentally introduced during colonization efforts. But we cannot plan for chemistry that doesn't exist anywhere in our solar system and operates according to molecular principles we've never observed in terrestrial or space-based laboratories. Consider this particularly disturbing possibility. Atlas's exotic chemistry doesn't immediately interfere with our atmospheric processes, but creates delayed action contamination that sabotages terraforming efforts months or years after initial deployment. Our atmospheric engineering systems begin operating normally, showing expected progress toward thicker atmosphere and warmer surface temperatures. But Gradually, exotic chemical reactions begin producing compounds that destroy the greenhouse gases we're trying to accumulate in Mars's atmosphere. By the time we recognize the problem, Atlas's chemistry has created irreversible atmospheric conditions that make traditional terraforming approaches permanently ineffective. The terraforming Terminator scenario becomes even more horrifying when we factor in the global distribution potential of any exotic chemistry Atlas deposits on Mars. The planet's notorious dust storms and atmospheric circulation patterns mean that contamination reaching any location on the surface would spread worldwide within months. Unlike localized chemical problems that we might be able to isolate and remediate, Atlas's chemistry would affect every atmospheric processor, every experimental ecosystem, every terraforming project we attempt anywhere on the planet. Here's what genuinely haunts me about the atmospheric engineering implications. If Atlas renders Mars permanently resistant to terraforming, it doesn't just delay our timeline for creating a second Earth, it could force humanity to completely abandon our most advanced plans for multi-planetary civilization and retreat to Earth indefinitely while we develop alternative planetary modification technologies or identify other worlds suitable for large-scale atmospheric engineering. The implications extend beyond just Mars to our entire approach to planetary habitability in our solar system. Venus presents even greater atmospheric engineering challenges than Mars, requiring massive atmospheric removal and chemical reprocessing efforts that make Mars terraforming look simple by comparison. The outer planet moons that we've identified as potential backup worlds, Europa, Enceladus, Titan, would require even more exotic atmospheric modification technologies. If Atlas demonstrates that planets can be chemically compromised by interstellar visitors in ways that make them permanently resistant to terraforming, it calls into question the fundamental viability of humanity's expansion beyond Earth using atmospheric engineering approaches. Still, the optimistic perspective suggests that terraforming challenges, even unexpected ones, typically accelerate technological development rather than ending it entirely. The Apollo program achieved unprecedented innovation when confronted with engineering problems that had never been solved before. If Atlas creates genuine obstacles to Mars terraforming, it could catalyze rapid advancement in atmospheric chemistry, exotic materials science, and planetary defense technologies that make our civilization more capable of handling future interstellar encounters. But this technological optimism assumes we'll have sufficient time and resources to develop solutions before Atlas's effects become irreversible. The solar conjunction period means we could lose critical months of atmospheric monitoring exactly when we most need to understand what's happening to our terraforming target world. By the time we can properly assess Atlas's impact on Mars's atmospheric chemistry, our terraforming timeline might already be compromised beyond recovery. What makes the terraforming Terminator scenario particularly insidious is the possibility that Atlas's chemistry creates atmospheric conditions that appear suitable for terraforming according to our current measurement techniques, but are actually incompatible with human biology in ways we won't discover until we've invested decades and hundreds of billions of dollars in planetary modification efforts. Mars could become a terraforming trap, a world that accepts atmospheric engineering but produces environmental conditions lethal to the human beings we're trying to establish there. The terraforming Terminator forces us to confront whether our plans for creating backup Earths adequately account for the possibility of chemical sabotage from interstellar sources carrying exotic chemistry that could interfere with atmospheric engineering in ways we can't predict or defend against. We've been designing planetary modification technologies assuming that the main challenges involve known physics and familiar chemistry. Atlas suggests we might need to develop terraforming approaches that are inherently resistant to exotic contamination from visitors we can't control or even effectively observe. Here's what genuinely terrifies me about Atlas's potential impact on terraforming. The cosmic anarchist could be teaching us that creating backup Earths isn't just a matter of applying sufficient technology and resources to planetary modification. It requires defending those worlds against ongoing threats from interstellar chemistry that could sabotage our most ambitious atmospheric engineering efforts at any point during the centuries-long terraforming process. When I examine the gravitational dynamics of Atlas's Mars encounter through the lens of orbital mechanics affecting Phobos, Mars's largest moon, what emerges is a scenario that could transform our backup planet's local space environment from a manageable frontier into a permanent debris field that makes human space operations around Mars catastrophically dangerous for centuries to come. Phobos orbits just 6,000 kilometers above Mars's surface, closer than most communication satellites orbit Earth, and this proximity, combined with the Moon's already precarious orbital situation, makes it extraordinarily vulnerable to gravitational perturbations from massive objects like Atlas passing through the Mars system. This is what makes my pulse race when I'm running gravitational interaction models. Phobos is already in a slowly decaying death spiral that will eventually cause it to crash into Mars in approximately 50 million years under normal circumstances. The Moon's orbit is gradually shrinking due to tidal forces from Mars's gravity, and its structural integrity is already compromised by billions of years of gravitational stress. Atlas's approach represents a massive gravitational perturbation that could accelerate Phobos's orbital decay from a 50 million year timeline to a matter of decades or even years. The mathematics of this accelerated destruction scenario are genuinely apocalyptic for Mars colonization planning. When Phobos finally disintegrates, whether naturally over millions of years or artificially accelerated by Atlas's gravitational influence, it won't create beautiful, stable ring systems like Saturn's majestic arrangements. Mars lacks the complex gravitational dynamics and shepherd moons necessary to organize debris into stable orbital patterns. Instead, Phobos's destruction will create a chaotic field of rocky fragments in low Mars orbit, essentially transforming the space around our backup planet into a cosmic shooting gallery that makes spacecraft operations extremely hazardous for geological timescales. Here's what keeps me awake: studying orbital decay calculations. Atlas doesn't need to directly collide with Phobos or even approach it closely to trigger catastrophic orbital instability. Even minor gravitational perturbations from Atlas's massive bulk passing through the Mars system could alter Phobos's orbital velocity by just a few meters per second, changes that seem insignificant on human scales but represent enormous modifications to orbital energy that compound exponentially over months and years. The timeline of Phobos destruction becomes a nightmare scenario for human expansion beyond Earth. Atlas approaches Mars in October 2025. If the gravitational interaction accelerates Phobos's orbital decay significantly, we could begin observing structural stress fractures and debris shedding within months or years, rather than geological epochs. By the time human colonists arrive at Mars in the 2030s and 2040s, they could find themselves attempting to establish civilization on a world surrounded by an increasingly dangerous debris field created by the slow-motion disintegration of Mars's largest moon. But let's step back and examine the rational assessment of gravitational perturbation risks. Atlas's approach at 30 million kilometers, while close in astronomical terms, is still extremely distant from Phobos's orbital position. The gravitational influence of one object on another decreases as the square of the distance between them, making significant orbital perturbations at such ranges highly improbable according to standard celestial mechanics calculations. Yet this is where the cumulative effects of multiple gravitational influences create genuinely unprecedented concerns that simple two-body calculations can't capture. Atlas's encounter with Mars occurs within a complex gravitational environment that includes not just Mars and Phobos, but also Deimos, Mars's smaller moon, the gravitational influences of Jupiter and other planets, and the overall solar gravitational field. Small perturbations from Atlas could trigger resonance effects or orbital instabilities that manifest months or years after the initial encounter. Consider this particularly disturbing scenario. Atlas's gravitational interaction with Mars doesn't immediately destabilize Phobos, but creates subtle changes to the Moon's orbital characteristics that accelerate its long-term decay rate. Instead of crashing into Mars in 50 million years, Phobos begins showing signs of structural failure within thousands of years. Still geological time from a planetary perspective, but human time from the standpoint of establishing permanent interplanetary civilization. The implications of accelerated Phobos destruction extend far beyond just creating orbital debris around Mars. Phobos serves crucial functions in current Mars exploration and colonization planning. The Moon's low gravity and close proximity to Mars make it an ideal staging area for cargo operations, fuel production, and orbital infrastructure that supports surface colonies. Mars colonization timelines assume we can establish permanent bases on Phobos that serve as logistical hubs for managing resources and personnel between Earth and Mars surface operations. If Atlas's encounter triggers Phobos destruction during the critical decades when human civilization is establishing permanent presence around Mars, we lose not just a potential colony location, but the entire logistical infrastructure that makes large-scale Mars colonization economically and operationally viable. The orbital debris field created by Phobos disintegration would make it extremely dangerous to establish replacement infrastructure in Mars orbit, potentially forcing all human operations to the planet's surface where they become much more expensive and vulnerable to environmental hazards. Here's where the Phobos destruction scenario becomes truly insidious. The timeline for Moon disintegration could coincide perfectly with humanity's most ambitious Mars expansion efforts. We're planning massive investments in Mars orbital infrastructure, surface colonies, and interplanetary transportation systems over the next 2 to 3 decades. If Atlas triggers Phobos destruction that creates a debris field around Mars during this critical expansion period, our colonization efforts could find themselves trapped on a planet's surface while orbital space becomes too dangerous for the spacecraft operations necessary to maintain contact with Earth and support growing colonial populations. The debris field scenario becomes even more horrifying when we factor in the cascade effects of orbital debris multiplication. Unlike Earth's orbital debris problem, which primarily affects specific altitude ranges, Mars's lower gravity means Phobos fragments would spread across multiple orbital zones, creating hazards for everything from communication satellites to cargo ships bringing supplies from Earth. Each collision between debris fragments creates additional smaller debris, leading to exponential multiplication of orbital hazards that could persist for thousands of years. What genuinely terrifies me about this orbital destruction timeline is our complete inability to prevent or mitigate Phobos collapse once gravitational instabilities begin. If Atlas triggers accelerated orbital decay, we have no technology capable of stabilizing Phobos's orbit or safely deorbiting the Moon before it creates a debris field. We would be forced to watch helplessly as Mars's space environment transforms from a manageable frontier into a permanent hazard zone that compromises humanity's expansion beyond Earth during the narrow historical window when such expansion is technologically feasible. The Phobos destruction protocol forces us to confront whether our Mars colonization plans adequately account for the vulnerability of orbital infrastructure to gravitational perturbations from interstellar visitors. We've been designing space-based logistics systems assuming that Mars's moons will remain stable and accessible throughout the decades required for successful colonization. Atlas suggests we might need to develop colonization approaches that don't depend on orbital infrastructure vulnerable to destruction by cosmic encounters we can't predict or control. Still, skeptics rightfully point out that Phobos has survived billions of years of cosmic encounters, asteroid impacts, and gravitational influences without being knocked out of orbit. The Moon's structural integrity, while compromised, has proven remarkably resilient to disruption throughout Mars's geological history. One cometary approach, even a massive one, is unlikely to fundamentally alter orbital dynamics that have remained stable for geological epochs. But this rational assessment misses the critical difference between geological stability and human timescale predictability. Previous gravitational disruptions occurred over millions of years, allowing Phobos's orbit to gradually adapt to new equilibrium conditions. Human Mars colonization operates on much shorter timescales. We need orbital predictability measured in decades, not millennia. If Atlas creates even minor acceleration of Phobos's decay rate, it could transform Mars' orbital operations from routine to catastrophically dangerous during the specific historical period when our species is attempting to establish permanent presence beyond Earth. What makes the Phobos scenario particularly cruel is the possibility that moon destruction occurs gradually enough that we don't recognize the threat, until orbital debris begins seriously compromising spacecraft operations. Atlas could trigger structural changes in Phobos that manifest as increased debris shedding, orbital instabilities, and surface fracturing over months or years rather than sudden catastrophic collapse. By the time we realize that Mars' orbital space is becoming increasingly hazardous, our colonization infrastructure could already be committed to operational approaches that depend on safe access to Mars' orbit. The destruction protocol transforms Atlas from a single astronomical event into a potential trigger for permanent changes to Mars's space environment that compromise human expansion beyond Earth for centuries. If Phobos becomes unstable due to Atlas's gravitational influence, we're not just losing a moon, we're potentially losing reliable access to Mars' orbital space during the critical decades when our species needs that access most desperately to establish sustainable interplanetary civilization. Here's what genuinely haunts me about the Phobos destruction timeline. The cosmic anarchist could be teaching us that establishing backup worlds isn't just a matter of reaching other planets and building habitats on their surfaces. It requires maintaining stable access to orbital space around those worlds throughout the centuries-long process of building self-sufficient interplanetary civilization. If interstellar, visitors routinely threaten orbital infrastructure through gravitational perturbations, our entire approach to multiplanetary expansion might need fundamental revision to account for cosmic threats we're only beginning to understand. The conjunction period that conceals Atlas's encounter with Mars creates what amounts to a perfect natural experiment in information warfare, social psychology, and the fundamental question of whether democratic societies can maintain rational policy decisions about existential risks when faced with weeks-long information blackouts during cosmic crises. What genuinely terrifies me isn't just the technical challenge of losing contact with our most sophisticated planetary monitoring systems. It's the realization that Atlas's timing transforms Earth itself into a laboratory for testing whether humanity is psychologically prepared for the isolation and uncertainty that will inevitably characterize interplanetary civilization. This is what keeps me staring at social media analytics and information propagation models. We're living through a historical moment when public trust in scientific institutions oscillates wildly between uncritical acceptance and paranoid rejection, when algorithmic amplification systems reward sensational content over factual accuracy, and when geopolitical tensions create perfect conditions for hostile actors to exploit information vulnerabilities during national emergencies. Atlas's approach during solar conjunction represents the first time in human history that we've lost contact with a world we're actively planning to colonize, during a period when that world faces potential contamination from exotic interstellar chemistry. The timeline of this information crisis unfolds with mathematical precision that seems almost deliberately designed to maximize social and political chaos. Atlas approaches Mars on October 3, 2025, while our primary information sources, the Mars Reconnaissance Orbiter, MAVEN, Perseverance rover, and our entire interplanetary communication network, fall silent due to solar interference. For approximately 3 weeks, the global population has no authoritative updates about what's happening to the planet we've promised will serve as humanity's backup world and the foundation of our multiplanetary future. Here's where the information warfare scenario becomes genuinely nightmarish. The absence of official data doesn't create a peaceful information vacuum that people fill, with patient waiting for facts to emerge. Instead, it creates a perfect breeding ground for speculation, conspiracy theories, and deliberate misinformation campaigns designed to serve political objectives completely unrelated to actual astronomical events. Social media platforms become battlegrounds where competing narratives about Atlas's threat potential spread faster than any fact-checking systems can respond. Consider this timeline of information contamination. Within hours of the communication blackout beginning, social media posts appear claiming that space agencies are deliberately concealing catastrophic damage to Mars to protect their budgets and public support for colonization programs. Within days, more sophisticated misinformation emerges, fabricated, leaked communications suggesting that Atlas has sterilized Mars's atmosphere, deepfake videos purporting to show surface devastation, false scientific papers claiming that interstellar objects routinely carry biological weapons designed to prevent the spread of intelligent life between star systems. But let's examine the rational perspective on information management during extended communication blackouts. NASA and the ESA have decades of experience managing public communication during space emergencies, equipment failures, and mission crises. Their established protocols emphasize scientific uncertainty, evidence-based assessment, and clear distinctions between confirmed observations and preliminary speculation. The space agencies have successfully maintained public confidence during much more severe actual emergencies than a routine communication blackout caused by predictable solar conjunction. Yet this is where Atlas creates genuinely unprecedented challenges for science communication that our standard information management protocols were never designed to handle. Previous space communication blackouts involved technical problems with known solutions and established repair procedures. Atlas introduces the possibility of permanent changes to planetary environments using exotic chemistry that we can't explain to public audiences in accessible terms because we don't understand it ourselves. The information warfare laboratory becomes truly insidious when we factor in the deliberate exploitation of the information vacuum by hostile foreign actors or domestic political organizations seeking to undermine confidence in American and European space exploration capabilities. The conjunction period creates perfect conditions for manufactured crises that serve geopolitical objectives, having nothing to do with actual cometary encounters or planetary contamination. Here's what makes this scenario particularly devious. Creating convincing misinformation about space disasters requires relatively modest resources that are accessible to state intelligence agencies, terrorist organizations, or even sophisticated individual hackers. Modern deepfake technology can produce convincing videos of Mars surface devastation. AI text generation systems can create scientific-sounding reports describing exotic contamination scenarios. Social media manipulation platforms can ensure global distribution of false information within hours of publication. Meanwhile, debunking sophisticated misinformation requires extensive scientific analysis, peer review processes, coordination between multiple international space agencies, and careful verification procedures that take weeks or months to complete properly. During Atlas's conjunction blackout, false information about Mars contamination could achieve global political impact long before accurate information becomes available to counter it. The implications of successful information warfare during Atlas's encounter extend far beyond temporary public confusion about a single astronomical event. Mars colonization requires sustained political and economic commitment across multiple decades, multiple electoral cycles, and multiple changes in government leadership. If hostile actors successfully convince significant portions of the global population that Mars has been permanently compromised by alien contamination, the resulting political backlash could delay human expansion beyond Earth by decades while we develop new planetary defense technologies or identify alternative backup worlds. What genuinely haunts me about the information warfare scenario is this. Even a completely benign Atlas encounter that poses no actual threat to Mars could create lasting damage to humanity's space exploration programs if misinformation campaigns successfully exploit the conjunction period to spread false narratives about planetary contamination. The scientific reality of what happens to our backup world during Atlas's approach matters less for long-term space policy than public perception of what happened. Still, The optimistic perspective suggests that our information ecosystems have evolved sophisticated verification mechanisms and that scientific literacy has improved significantly over recent decades. The global space community includes thousands of independent observers, amateur astronomers, university researchers, and citizen scientists who can provide verification and alternative perspectives on official agency communications. Misinformation about major astronomical events typically gets corrected relatively quickly by distributed networks of knowledgeable enthusiasts. But this technological optimism seriously underestimates the speed and scale at which carefully crafted misinformation can spread through social media platforms during crisis periods when public demand for information exceeds the supply of authoritative sources. Atlas's conjunction blackout could last 3 weeks, more than sufficient time for sophisticated disinformation campaigns to achieve permanent political damage to space exploration programs, even if the false information is eventually corrected by scientific authorities. The Information Warfare Laboratory forces us to confront uncomfortable questions about the psychological infrastructure underlying human expansion beyond Earth. We're planning to establish permanent settlements on worlds that will periodically become uncommunicable from our home planet due to predictable astronomical events, equipment failures, or cosmic disasters. Are we prepared to maintain rational political support for multi-planetary civilization when cosmic encounters routinely demonstrate our inability to provide real-time updates about threats to our backup worlds? Here's what makes Atlas's information challenge uniquely dangerous. It's testing whether democratic societies can make rational decisions about existential risks when faced with incomplete information during crisis periods. If we can't maintain public confidence in space exploration programs during a few weeks of communication blackout with Mars, how will we handle the years-long isolation periods that interplanetary colonies will inevitably experience during their development toward self-sufficiency? The cosmic anarchist isn't just testing our technological preparedness for interstellar encounters. It's potentially revealing that our species lacks the psychological resilience necessary for multiplanetary civilization. Atlas could teach us that the greatest threat to humanity's expansion beyond Earth isn't exotic chemistry or gravitational perturbations. It's our own inability to process uncertainty and maintain rational discourse when cosmic events remind us how little control we actually have over the universe we're trying to expand into. The potential for Atlas to serve as an interstellar biological warfare vector represents perhaps the most disturbing aspect of its encounter with Mars, and I use the term biological warfare not in the sense of deliberate military action, but in the much more terrifying sense of cosmic-scale contamination that could render our backup planet permanently hostile to terrestrial life forms through mechanisms we can't predict, detect, or counteract with current medical or biological sciences. The exotic organic compounds sublimating from Atlas's nucleus during its approach to Mars don't just represent unknown chemistry, they potentially represent the first large-scale introduction of alien biochemistry into our solar system during the historical period when human civilization is actively planning to establish permanent settlements beyond Earth. This is what makes my hands shake when I examine the biological implications of interstellar panspermia in reverse. Every previous model of how life might spread between worlds assumes that biological contamination travels from inhabited planets to sterile environments, gradually introducing familiar biochemistry that operates according to principles we understand. Atlas represents the opposite scenario, exotic biochemistry from interstellar space, potentially contaminating a world we're planning to inhabit with compounds that were literally cooked by cosmic radiation for 30,000 years, in environments we've never studied. The European Space Agency's preliminary spectroscopic analysis of Atlas's coma reveals organic signatures that don't just differ from terrestrial biochemistry, they suggest molecular structures that could only have formed under radiation conditions that would be immediately lethal to any Earth-based life form. These aren't variations on familiar themes of amino acids and nucleotide bases. They represent entirely alien approaches to organic chemistry that evolved in the radiation environment of deep space, where stellar winds and cosmic rays create chemical reactions impossible under planetary conditions that support conventional biology. Here's where the biological warfare scenario becomes genuinely nightmarish. Mars's surface environment, with its high radiation levels and reactive perchlorate chemistry, could serve as a perfect incubation chamber for interactions between Atlas's exotic organics and any indigenous Martian biochemistry that might exist in subsurface environments. Instead of simply contaminating a sterile world, Atlas could trigger biochemical reactions between alien chemistry from interstellar space and potentially active biological systems that have evolved on Mars over billions of years. The implications of this biochemical mixing are staggering in their unpredictability. We have no models for understanding how organic compounds forged in interstellar radiation environments might interact with Martian biochemistry, if such exists. We have no laboratory experience with radiation-modified organic chemistry operating under Martian surface conditions. We have no medical knowledge about how such exotic compounds might affect human physiology during extended exposure periods required for successful colonization. But let's examine the rational counter-argument about biological contamination risks. Organic chemistry operates according to universal principles regardless of where it originates. Complex organic molecules, even exotic ones, are bound by the same quantum mechanical rules that govern all chemical interactions. The probability that interstellar organic compounds would prove specifically toxic to terrestrial biology is relatively low given the fundamental similarities in carbon-based chemistry throughout the universe. Yet this rational assessment misses the critical factor of concentration and delivery mechanism. Previous exposure to interstellar organic chemistry occurred through microscopic cosmic dust particles and individual cosmic ray interactions spread across geological time. Atlas represents a massive, concentrated delivery of exotic organics directly to Mars's surface during the specific historical period when human colonization is transitioning from robotic exploration to permanent settlement. Consider this particularly disturbing biological timeline. Atlas's exotic organics reach Mars and begin interacting with subsurface chemistry during the conjunction period when we can't observe the results. These interactions don't create immediately obvious toxic effects that our instruments could detect. Instead, they produce subtle biochemical changes that gradually alter Mars's compatibility with terrestrial biology over months or years. By the time human colonists arrive in the 2030s, Mars appears completely suitable for habitation according to all our pre-Atlas testing protocols, but extended exposure to the modified Martian environment begins causing health problems that don't match any terrestrial medical conditions. The biological warfare vector becomes even more insidious when we factor in the global distribution potential of atmospheric contamination. Mars's dust storms and thin atmospheric circulation would spread any exotic organics across the entire planet within months of Atlas's encounter. Unlike localized contamination that we might be able to avoid or remediate, biological warfare through atmospheric distribution would affect every landing site, every planned colony location, every agricultural area we're hoping to develop for sustainable colonization. What genuinely terrifies me about this biological scenario is the possibility of delayed action toxicity that doesn't manifest until human colonists have already committed years of their lives and billions of dollars of infrastructure to Mars settlement. The exotic organics could interact with human biochemistry in ways that produce slow, cumulative health effects, neurological degradation, reproductive failures, immune system compromise, that don't become apparent until months or years after initial exposure. Here's where the timing becomes cosmically cruel. Atlas's biological contamination of Mars occurs precisely during the narrow historical window when human civilization has developed the technology for interplanetary expansion, but hasn't yet developed the medical science necessary to understand or treat exposure to exotic biochemistry. Our colonists could find themselves trapped on a world that's slowly killing them, through mechanisms that terrestrial medicine has no experience treating. The biological warfare scenario forces us to confront whether our Mars colonization plans adequately account for the possibility of biochemical contamination from interstellar sources carrying organic chemistry that operates according to principles we don't understand. We've been designing life support systems and medical facilities for Mars colonies, assuming that the main biological hazards involve familiar challenges: radiation exposure, atmospheric toxicity from known compounds, potential exposure to indigenous Martian microorganisms that might operate according to recognizable biological principles. Still, skeptics rightfully point out that Mars shows no evidence of being biologically compromised by previous encounters with interstellar chemistry over billions of years of geological history. If exotic interstellar organics posed fundamental threats to planetary biochemistry, we would expect to see clear evidence of biological disruption in Mars's geological record or in the planet's current atmospheric and surface chemistry. But this rational perspective assumes that previous interstellar contamination events were comparable in scale and concentration to Atlas's potential delivery of exotic organics. We have no precedent for understanding how massive doses of interstellar biochemistry might affect planetary environments during timescales relevant to human colonization, rather than geological adaptation. What makes the biological warfare vector particularly insidious is our complete inability to test or prepare for exposure to biochemistry that doesn't exist in any Earth-based laboratory. If Atlas delivers exotic organics to Mars that prove toxic to human physiology, we have no opportunity to develop treatments or protective technologies before our colonists are already exposed to the contaminated environment. The cosmic anarchist could be teaching us that expanding beyond Earth's protective biosphere isn't just a matter of developing better life support technology and radiation shielding. It requires defending ourselves against biological threats from interstellar sources that operate according to biochemical principles we've never encountered and can't anticipate based on terrestrial experience. Here's what genuinely haunts me about Atlas's biological implications. If interstellar visitors routinely carry exotic biochemistry that could compromise planetary habitability for terrestrial life forms, then our entire approach to identifying and developing backup worlds needs fundamental revision. We've been selecting Mars as our primary colonization target based on its apparent compatibility with Earth-based biology, but we haven't factored in the possibility that interstellar chemistry could transform any planet into a biological trap that appears suitable for habitation until it's too late to protect the humans we've sent there. The financial implications of Atlas's encounter with Mars extend far beyond the immediate costs of monitoring an interstellar visitor into the realm of economic catastrophe that could destroy the entire foundation of humanity's multiplanetary expansion during the narrow historical window when such expansion is economically and technologically feasible. What genuinely terrifies me when I examine the economics of space colonization isn't just the direct costs of responding to potential contamination or orbital debris. It's the possibility that Atlas could trigger a crisis of confidence in Mars as an investment destination that cascades through the entire global space economy worth hundreds of billions of dollars. This is what keeps me awake, studying economic impact models. Mars colonization represents one of the largest and most speculative investment commitments in human history, requiring sustained financial commitment across multiple decades from both governmental space agencies and private aerospace companies. The entire economic foundation of this investment depends on maintaining confidence that Mars will remain suitable for human habitation and economic development throughout the time periods required for establishing self-sufficient interplanetary civilization. Atlas's encounter occurs at the worst possible moment in the economic timeline of Mars development. We're currently in the critical transition period when Mars colonization is shifting from government-funded scientific research programs to private commercial ventures that require massive capital investments based on projected returns from interplanetary trade, resource extraction, and real estate development. If Atlas creates any significant doubt about Mars's long-term habitability or accessibility, it could trigger divestment cascades that destroy the financial foundation for human expansion beyond Earth. Here's what makes the economic scenario particularly devastating. The conjunction period that conceals Atlas's encounter creates weeks of investment uncertainty during which financial markets must price Mars-related investments without access to authoritative information about what's actually happening to humanity's primary colonization target. This uncertainty occurs in economic environments where aerospace stock prices, government budget allocations, and private investment decisions are increasingly sensitive to any suggestion that Mars colonization might face unexpected obstacles or delays. The mathematics of economic cascade failures in speculative markets are genuinely apocalyptic for space development programs. Even temporary uncertainty about Mars's habitability could trigger massive sell-offs of aerospace stocks, cancellation of planned private missions, and political pressure on government agencies to redirect Mars colonization budgets toward alternative programs with more predictable returns on investment. The entire multi-hundred-billion-dollar space economy could experience rapid contraction based on speculation about potential problems rather than actual confirmed threats. But let's examine the rational perspective on economic resilience in the space sector. The aerospace industry has successfully weathered numerous mission failures, technical setbacks, budget cuts, and political changes without abandoning long-term space exploration goals. Mars colonization timelines already factor in significant technical and financial risks, including the possibility of encountering unexpected challenges that require additional investment and timeline adjustments. Atlas represents just one additional variable in economic planning that already assumes significant uncertainty and risk. Yet this rational assessment misses the critical difference between gradual technical challenges that can be solved through additional engineering effort and sudden existential questions about whether Mars remains suitable for human colonization at all. Previous economic disruptions in the space sector involved problems with known solutions, technical failures that could be fixed, budget constraints that could be managed through political negotiation, timeline delays that could be addressed through improved planning and resource allocation. Atlas introduces the possibility of fundamental unsuitability of our primary colonization target due to exotic contamination that we can't remediate, gravitational perturbations that make Mars orbital operations permanently dangerous, or biochemical changes that render the planet hostile to human habitation. These aren't engineering problems that can be solved through additional investment. They're existential challenges that could make Mars colonization economically impossible regardless of technological advancement or financial commitment. Consider this timeline of economic devastation. Atlas approaches Mars during the conjunction blackout period, while financial markets experience maximum uncertainty about what's happening to humanity's backup world. Even if Atlas's encounter proves completely benign, the weeks of uncertainty create opportunities for market manipulation, political opportunism, and competitor sabotage that permanently damage confidence in Mars colonization as a viable investment destination. The implications extend beyond just Mars-specific investments to the entire economic foundation of multi-planetary civilization. If Atlas demonstrates that interstellar visitors can routinely threaten planetary habitability through mechanisms we can't predict or control, it calls into question the fundamental economic assumptions underlying all space colonization efforts. Why invest in establishing human settlements on worlds that could be contaminated or destabilized by cosmic encounters we can't defend against? Here's where the economic apocalypse becomes truly insidious. Atlas could trigger permanent changes to how financial markets and government budgets evaluate space colonization risks, making it impossible to secure the sustained investment required for successful multiplanetary expansion, regardless of whether Atlas actually poses any real threat to Mars. The economic damage from uncertainty could prove more devastating than any physical damage Atlas might inflict on our backup world. The economic warfare potential of Atlas's encounter creates opportunities for foreign competitors or hostile actors to exploit information vulnerabilities for financial gain or strategic advantage. Short-selling aerospace stocks while spreading misinformation about Mars contamination could generate enormous profits while simultaneously undermining American and European space leadership. Economic attacks during the conjunction period could achieve permanent damage to space programs worth hundreds of billions of dollars using relatively modest investments in information warfare and market manipulation. Still, the optimistic economic perspective suggests that space colonization represents such fundamental importance to human civilization's long-term survival that temporary market disruptions and political uncertainty won't derail sustained commitment to multi-planetary expansion. The economic value of establishing backup worlds transcends normal investment calculations. It represents insurance for human species, survival that justifies continued commitment despite short-term financial volatility. But this perspective assumes that political and economic decision-makers will maintain rational long-term thinking about existential risks during crisis periods when immediate market pressures and electoral considerations dominate policy choices. Atlas's conjunction blackout occurs during a period when space program budgets face increasing scrutiny and competition from domestic priorities like healthcare, education, and infrastructure development. What genuinely terrifies me about the economic implications is the possibility that Atlas doesn't need to actually damage Mars to destroy humanity's multiplanetary future. It just needs to create sufficient economic uncertainty to trigger divestment cascades that make Mars colonization financially impossible during the narrow historical window when our technology and resources are adequate for such ambitious undertakings. The economic apocalypse scenario forces us to confront whether our approach to financing multiplanetary civilization adequately accounts for the vulnerability of speculative investments to uncertainty about cosmic threats we can't predict or control. We've been building the financial foundation for space colonization, assuming that the main economic risks involve predictable technical challenges and political changes, not existential questions about planetary habitability due to interstellar encounters. Here's what haunts me about Atlas's economic timing. The cosmic anarchist arrives at the precise moment when Mars colonization is transitioning from government-funded research to commercial investment, creating maximum vulnerability to economic disruption during the phase when sustained private capital commitment is most essential for establishing self-sufficient interplanetary civilization. The financial cascade effects could prove more devastating to humanity's expansion beyond Earth than any direct physical damage Atlas might inflict on Mars itself. Even a completely harmless interstellar visitor could end human multiplanetary civilization through economic warfare that exploits uncertainty and fear to destroy the financial infrastructure underlying our species' most ambitious survival strategy. Atlas forces humanity to confront the most disturbing question of our species' expansion beyond Earth. Are we genuinely prepared for life in a universe where interstellar visitors arrive without warning-carrying chemistry we can't predict, operating on timelines we can't control, and testing our readiness for cosmic citizenship through encounters that reveal just how little we understand about the true nature of interplanetary survival? What keeps me staring into the void of space policy implications isn't the specific details of Atlas's approach to Mars, but the growing realization that this encounter is functioning as a cosmic mirror that reflects our civilization's fundamental unpreparedness for the challenges that define genuine multiplanetary existence. This is what genuinely terrifies me about the deeper implications of Atlas's timing. We're witnessing the first real test of whether human civilization possesses the technological sophistication, psychological resilience, and cultural adaptability necessary to survive as a spacefaring species in a universe that operates according to rules we've barely begun to understand. Every aspect of Atlas's encounter, the conjunction period that blinds our observations, the exotic chemistry that challenges our models, the gravitational dynamics that threaten orbital infrastructure, reveals gaps in our preparedness that could prove fatal during future interstellar encounters. The cosmic mirror effect becomes unmistakable when we examine our collective response patterns to Atlas's approach. Some segments of human civilization view the encounter as an exciting opportunity for scientific discovery and technological advancement. Others interpret it as evidence that space expansion exposes our species to cosmic threats that planet-bound civilizations never encounter. Still others see it as proof that we're not yet ready for multiplanetary existence and should focus on solving terrestrial problems before attempting interstellar encounters. But here's where the mirror becomes truly disturbing. Our response to Atlas reveals more about humanity's psychological and cultural readiness for cosmic citizenship than Atlas's actual behavior reveals about interstellar objects or planetary contamination risks. The encounter is functioning as a Rorschach test that exposes our deepest fears and assumptions about cosmic vulnerability, technological control, and species survival in environments we don't fully comprehend. Let's examine the rational perspective on cosmic readiness. Humanity has been dealing with unpredictable natural disasters, technological failures, environmental changes, and existential risks throughout our entire evolutionary history. Our species' survival has always depended on adaptability, innovation, and collective problem-solving under conditions of extreme uncertainty. Atlas doesn't represent a fundamentally different category of challenge. It's simply the latest in a long series of tests that have shaped human civilization through successful adaptation to threatening environments. Yet this is where Atlas's interstellar origin creates genuinely unprecedented psychological challenges that make our previous survival experiences potentially irrelevant as preparation for multiplanetary existence. Every previous threat to human civilization, volcanic eruptions, asteroid impacts, climate changes, technological disasters, warfare, originated within systems we could eventually understand, predict, and potentially control through technological advancement and cultural adaptation. Atlas comes from outside our solar system, carrying 30,000 years of exposure to environments we've never experienced, operating according to chemical and physical dynamics we've never observed, arriving on timelines that have nothing to do with human convenience or preparedness. The encounter forces us to confront the possibility that expanding beyond Earth exposes our species to categories of threats that are genuinely unpredictable and potentially uncontrollable through any foreseeable technological advancement. Consider the deeper evolutionary question that Atlas poses. If our backup planet can be fundamentally altered by visitors from other star systems, what does this suggest about the long-term viability of human expansion beyond Earth's protective systems? Are we building multiplanetary civilization on the assumption that planetary environments remain stable and predictable when the universe actually operates according to much more chaotic and threatening principles? Here's the scenario that genuinely haunts me from a species survival perspective. Atlas isn't unique. Interstellar visitors like this arrive in our solar system regularly on geological timescales, every few thousand or million years, carrying exotic chemistry, gravitational perturbations, and contamination potential that routinely challenge planetary habitability. Our species has simply never been technologically advanced enough to detect such encounters before Atlas. As we expand beyond Earth and establish colonies throughout the solar system, we're actually increasing our exposure to threats that planet-bound civilizations never encounter. Instead of reducing existential risk through multiplanetary distribution, we might be exposing human settlements to cosmic hazards that could eliminate our entire interplanetary civilization simultaneously through mechanisms we can't predict or defend against. The cosmic mirror forces us to ask whether humanity's expansion into space represents genuine evolutionary advancement toward greater resilience and survival capability, or simply the exposure of our species to hazards that we're not yet sophisticated enough to recognize or prepare for effectively. Atlas might be teaching us that becoming a spacefaring civilization requires technological and cultural capabilities we haven't yet developed. Still, the optimistic interpretation suggests that Atlas represents exactly the kind of challenge that accelerates human evolution and technological development in directions that increase our species' long-term survival prospects. Just as previous existential threats have historically driven innovation, cultural adaptation, and technological breakthrough, interstellar encounters could catalyze developments in planetary defense, exotic chemistry analysis, gravitational manipulation, and space-based civilization infrastructure that make humanity genuinely capable of thriving in cosmic environments. But this evolutionary optimism assumes our species can adapt quickly enough to survive the learning process without experiencing catastrophic failures that eliminate human civilization during our most vulnerable expansion phases. Atlas arrives when we're advanced enough to detect interstellar threats, but not yet robust enough to defend against them effectively. We're cosmic adolescents encountering adult challenges, and the stakes involved in establishing multiplanetary civilization mean we might not receive multiple opportunities to learn from our mistakes. The mirror of cosmic unreadiness ultimately reflects our species' position at a critical juncture in evolutionary development, advanced enough to attempt expansion beyond Earth, but not yet sophisticated enough to understand or control the cosmic environment we're entering. Atlas is testing whether humanity can make the psychological and technological leap from planetary to interplanetary existence, or whether we'll be forced to retreat to Earth and remain a single-world species until we develop capabilities adequate for surviving in the universe as it actually operates rather than as we've imagined it to be. What makes Atlas's cosmic mirror particularly cruel is its timing during the narrow historical window when human civilization possesses the technology for interplanetary expansion, but hasn't yet committed sufficient resources to developing the planetary defense and cosmic adaptation capabilities that genuine spacefaring species probably require for long-term survival. The encounter could be revealing that we're attempting multi-planetary civilization several centuries too early in our technological and cultural development. Here's what genuinely terrifies me about what Atlas's mirror is showing us: the possibility that our species' expansion beyond Earth isn't advancing human evolution toward greater cosmic capability, but simply exposing the fundamental limitations that will confine humanity to our home world until we develop genuine understanding of and defensive capability against the universe as it actually functions, chaotic, unpredictable, and occasionally hostile to the kind of technological civilization we're attempting to spread across multiple worlds. The cosmic anarchist has arrived as our final exam in interstellar readiness, and we're discovering that we might not yet possess the knowledge, technology, or cultural sophistication necessary to pass the test that determines whether humanity deserves to survive among the stars. What genuinely keeps me awake isn't just Atlas's approach to Mars on October 3rd, but the realization that we might be witnessing the beginning of a transformation timeline that extends decades into humanity's future, fundamentally altering how our species approaches expansion beyond Earth based on what we learn, or fail to learn, from this first major encounter with genuine interstellar chemistry in the modern technological age. The real test of Atlas isn't what happens during those crucial weeks in October when Mars disappears behind the Sun, but how human civilization adapts its multi-planetary ambitions based on whatever we discover when communication resumes and we begin analyzing the aftermath. This is what makes my pulse race when I examine the long-term implications. Atlas represents a watershed moment in human space exploration that divides our species' expansion beyond Earth into before and after periods. Before Atlas, we planned multi-planetary civilization, assuming that the main challenges involved familiar engineering problems: life, support systems, radiation shielding, atmospheric processes, agricultural systems, operating in predictable environments governed by physics and chemistry we understand. After Atlas, every aspect of space colonization must factor in the possibility of exotic contamination, gravitational perturbations, and cosmic encounters that operate according to principles we're only beginning to comprehend. The transformation timeline unfolds across multiple phases that could reshape human civilization over the next century. Phase 1 occurs during Atlas's approach and the conjunction blackout period, Weeks of uncertainty when we lose contact with Mars, while an interstellar visitor potentially alters our backup planet through mechanisms we can't observe or predict. Phase 2 begins when communication resumes in late November 2025, and we start analyzing whatever changes Atlas may have wrought on Mars's atmosphere, surface chemistry, and orbital environment. But here's where the timeline becomes truly transformative. Phase 3 could extend across decades as we gradually understand the full implications of Atlas's encounter for Mars colonization, planetary defense, and humanity's long-term survival strategy. If Atlas demonstrates that interstellar visitors can routinely compromise planetary habitability through exotic contamination or gravitational disruption, it forces complete revision of our approach to identifying, preparing, and defending backup worlds for human settlement. Phase 4 represents the most profound transformation, the development of genuinely spacefaring human civilization that's psychologically and technologically adapted to thriving in a universe where cosmic encounters routinely test our species' resilience, adaptability, and defensive capabilities. This isn't just about building better rockets or life support systems. It's about evolving human culture, economics, and governance systems that can maintain stability and progress despite ongoing exposure to threats we can't predict or control. Let's examine the rational perspective on transformation timelines. Human civilization has successfully adapted to numerous existential challenges throughout history, without abandoning fundamental goals or restructuring society completely. The development of nuclear weapons, climate change, global pandemics, and technological disruptions have all required significant adaptation without preventing continued progress toward improved living conditions and expanded human capabilities. Atlas represents another challenge that will drive innovation and adaptation without necessarily forcing fundamental revision of our expansion beyond Earth. Yet this rational assessment underestimates the unique characteristics that make Atlas fundamentally different from previous challenges to human civilization. Nuclear weapons, climate change, and pandemics all operate within Earth's environmental systems using physics and chemistry that we understand reasonably. Well, Atlas introduces variables from outside our solar system that have never been part of human experience and might require technological and cultural adaptations we haven't yet imagined. Consider this transformation scenario. Atlas's encounter proves completely benign. No contamination, no gravitational disruption, no lasting changes to Mars's habitability. But the experience of losing contact with our backup world during a potential crisis forces recognition that interstellar encounters represent ongoing threats that require permanent defensive capabilities. Human space exploration transforms from optimistic expansion into guarded, heavily defended colonization that factors in regular threats from cosmic visitors. The economic implications of this transformation could prove as significant as the technological challenges. If Atlas demonstrates that planetary defense against interstellar threats represents a necessary component of multiplanetary civilization, it adds massive costs and complexity to space colonization budgets. Instead of investing resources primarily in transportation, habitats, and life support systems, human expansion beyond Earth must factor in planetary defense networks, exotic chemistry analysis systems, and cosmic threat monitoring capabilities. Here's where the transformation timeline becomes particularly significant. Atlas arrives during the narrow historical window when human civilization possesses adequate technology for interplanetary expansion, but hasn't yet committed sufficient resources to make multiplanetary existence irreversible. This is what genuinely terrifies me about the transformation timeline. We might be witnessing the moment when humanity discovers that becoming a truly spacefaring civilization requires capabilities we haven't developed and psychological adaptations we haven't made. Atlas could be teaching us that the universe operates as a continuous examination system where cosmic encounters regularly test whether intelligent species deserve to survive beyond their homeworlds. The transformation phases could unfold with brutal efficiency. Phase 1. Atlas approaches Mars while we're blind to the encounter. Phase 2. we discover whatever changes have occurred to our backup world. Phase 3. We realize that interstellar visitors represent routine rather than exceptional threats to planetary habitability. Phase 4. Human expansion beyond Earth transforms from optimistic colonization into heavily defended survival operations that must constantly prepare for the next cosmic test. But here's the timeline element that makes Atlas particularly transformative. This encounter occurs precisely when human civilization is transitioning from single-planet to multi-planet existence. If we learn the wrong lessons from Atlas, either overconfidence that interstellar threats are manageable or panic that space expansion is too dangerous, we could lock in approaches to multi-planetary civilization that determine our species' survival prospects for centuries. The rational perspective suggests that Atlas, like previous existential challenges, will drive innovation and adaptation that ultimately strengthen human civilization. Nuclear weapons led to international cooperation frameworks. Climate change is accelerating clean energy development. Pandemics advanced medical science and global health infrastructure. Atlas could catalyze breakthroughs in planetary defense, exotic chemistry analysis, and space-based civilization design that make humanity genuinely capable of cosmic citizenship. Yet the transformation timeline assumes we have sufficient time to develop necessary capabilities before the next interstellar encounter tests our preparedness. If Atlas triggers changes we can't reverse or reveals vulnerabilities we can't address with current technology, the transformation could prove catastrophic rather than adaptive. What genuinely haunts me about Atlas's transformation potential is the possibility that this encounter represents humanity's cosmic graduation exam, and we might be about to discover that we're not yet ready to pass the tests that determine whether intelligent species survive their expansion beyond home worlds. The moment of truth arrives not with Atlas's October approach, but in late November 2025, when Mars emerges from behind the Sun and humanity receives its first communication from the Red Planet in over a month. What we discover in those initial data transmissions will determine whether Atlas's encounter represents a routine astronomical event that confirms our readiness for multiplanetary civilization, or a cosmic catastrophe that forces complete revision of humanity's expansion beyond Earth. The Revelation Protocol isn't just about analyzing atmospheric chemistry or orbital mechanics. It's about interpreting the first major test of whether our species understands the universe well enough to survive as cosmic citizens. This is what makes my hands shake when I imagine receiving those first post-conjunction transmissions from Mars. We won't just be analyzing scientific data about atmospheric composition, surface chemistry, or orbital dynamics. We'll be reading the universe's assessment of humanity's preparedness for interplanetary existence. Every measurement, every spectrographic signature, every orbital calculation becomes part of a cosmic report card that could determine our species' future among the stars. The Revelation timeline unfolds across multiple critical phases. First contact occurs when our deep space network re-establishes communication with Mars orbiters and surface assets. Within hours, we'll have preliminary data about Mars's atmospheric condition, surface temperature, orbital stability, and the operational status of our robotic exploration infrastructure. But these initial readings might reveal more questions than answers about what actually transpired during Atlas's encounter. Phase 2 involves detailed analysis of any changes to Mars's environment that occurred during the conjunction blackout. Our instruments will have been recording continuously throughout Atlas's approach, storing terabytes of data about atmospheric chemistry fluctuations, surface composition changes, electromagnetic anomalies, and orbital perturbations. The Revelation Protocol requires comparing this data to pre-Atlas baselines to identify any modifications to our backup planet's habitability. Here's where the revelation becomes truly momentous. Phase 3 extends across months as we attempt to understand the long-term implications of whatever we discover. If Atlas deposited exotic chemistry on Mars, we need to determine whether these compounds pose threats to human colonization efforts. If gravitational interactions affected Mars's orbital mechanics or lunar stability, we must calculate the timeline and severity of resulting changes. If electromagnetic effects disrupted atmospheric dynamics, we need to assess impacts on terraforming viability. But let's consider the rational perspective on revelation protocols. NASA and ESA have extensive experience analyzing unexpected data from Mars missions and drawing appropriate conclusions about planetary conditions and colonization planning. Our scientific institutions possess robust peer review processes, international collaboration frameworks, and evidence-based decision-making protocols that can accurately assess Atlas's impact on Mars habitability without overreacting to anomalous readings or preliminary data. Yet this rational assessment assumes that Atlas's encounter falls within the range of phenomena our current scientific frameworks can analyze and interpret accurately. If Atlas introduced genuinely exotic variables, chemistry that operates according to principles we haven't studied, gravitational effects that don't match our orbital mechanics models, electromagnetic anomalies that suggest unknown physical processes, our standard revelation, protocols might prove inadequate for understanding what actually happened to our backup world. The revelation protocol becomes genuinely terrifying when we factor in the possibility of delayed action effects that don't manifest immediately after communication resumes. Atlas might have triggered chemical reactions, orbital instabilities, or atmospheric changes that develop gradually over months or years, rather than producing immediate observable effects. Our initial post-conjunction assessment could declare Mars completely unaffected, while missing slow-developing contamination or destabilization that compromises the planet's long-term habitability. Consider this nightmare revelation scenario. Mars appears completely normal when communication resumes in November 2025. Atmospheric readings match pre-Atlas baselines, surface composition shows no anomalous chemistry, orbital mechanics remain within expected parameters. NASA and ESA declare Atlas's encounter a non-event that poses no threat to Mars colonization planning. But months later, subtle chemical changes begin manifesting. Exotic organic compounds that weren't immediately detectable, atmospheric reactions that required time to develop, surface chemistry modifications that interact with planned terraforming systems in unexpected ways. The Revelation Protocol forces us to confront the fundamental limitation of human knowledge when interpreting cosmic events. We can only understand what our instruments can detect and our theories can explain. If Atlas operates according to principles we haven't discovered or introduces variables we haven't learned to measure, our revelation assessment could be completely wrong about the encounter's significance for Mars colonization. Here's what genuinely terrifies me about the revelation timeline: the possibility that we'll interpret Atlas's encounter incorrectly and make catastrophic decisions about humanity's multiplanetary future based on incomplete understanding of what actually happened to our backup world during those crucial weeks behind the sun. Still, the optimistic perspective suggests that Atlas's revelation, regardless of what it reveals, advances human understanding of cosmic threats and planetary defense requirements. Even if we initially misinterpret the encounter's significance, continued observation and analysis will eventually provide accurate assessment of any long-term effects on Mars habitability. Science operates through progressive refinement of understanding rather than requiring perfect initial interpretation. But this scientific optimism assumes we have sufficient time to correct initial misunderstandings before making irreversible commitments to Mars colonization infrastructure. If we interpret a benign Atlas encounter as evidence that interstellar threats are manageable, we might proceed with colonization planning that leaves human settlements vulnerable to future cosmic encounters. If we overreact to harmless anomalies, we might abandon Mars colonization during the narrow window when it's technologically and economically feasible. The Revelation Protocol transforms Atlas from a single astronomical event into the foundation for humanity's understanding of cosmic citizenship. What we learn or think we learn from interpreting this encounter will shape space exploration policy, planetary defense development, and colonization planning for decades to come. What if the greatest catastrophe isn't that Atlas destroys Mars, but that it saves humanity, and we never recognize the cosmic warning it was designed to deliver? Here's the possibility that genuinely terrifies me as we approach the climax of this interstellar encounter. Atlas passes harmlessly by Mars. Our backup planet emerges from the conjunction period completely unaffected, and we interpret this outcome as confirmation that interstellar visitors pose no significant threat to human expansion beyond Earth, when Atlas might actually have been testing whether our species possesses the wisdom to recognize existential warnings before they become existential catastrophes. This is what keeps me staring at the deeper implications long after the astronomical data has been analyzed and filed away. December 2025 arrives with Mars showing no signs of contamination, no orbital instabilities, no atmospheric anomalies. NASA and ESA announced that Atlas's encounter posed no significant threat to our backup world. Public attention shifts to other concerns. Mars. Colonization programs continue as planned. But we learn exactly the wrong lesson from our first major encounter with interstellar chemistry in the modern technological age. Instead of recognizing that Atlas represented a cosmic examination of our preparedness for multiplanetary existence, we conclude that interstellar threats are essentially manageable using our current detection and assessment capabilities. Mars colonization proceeds without developing robust planetary defense systems. We establish permanent settlements, assuming that our backup world is secure from cosmic contamination, because one interstellar visitor proved harmless. Then the next cosmic anarchist arrives, perhaps in 2045, perhaps in 2067, perhaps not for several centuries. This one carries different chemistry, operates under different physical conditions, approaches during periods when Mars's atmospheric dynamics make the planet more vulnerable to exotic contamination. Our thriving colonies are established, our infrastructure is committed, our population has grown to include millions of humans who depend on Mars as their permanent home. And we're completely unprepared because Atlas taught us that interstellar encounters are routine rather than potentially catastrophic. But here's where the final warning becomes truly insidious. What if Atlas was actually a test administered by an intelligence capable of interstellar travel, designed to assess whether humanity has developed the planetary defense, capabilities and cosmic awareness necessary for survival as a multiplanetary species? Our response to Atlas, treating it as a scientific curiosity rather than a potential existential threat, signals to these cosmic examiners that we're not yet ready for genuine membership in whatever community exists among spacefaring civilizations. The implications of failing this cosmic examination extend far beyond just missing opportunities for contact with alien intelligences. Future interstellar visitors might arrive with less benign intentions, or the universe itself might operate according to selection principles that eliminate species incapable of recognizing and preparing for cosmic threats before they become survival challenges. Let's examine the rational counterargument. Successful navigation of Atlas's encounter, even if it poses no actual immediate threat, demonstrates exactly the kind of scientific monitoring and risk assessment capabilities that humanity needs for sustainable expansion beyond Earth. Our ability to detect, track, and analyze interstellar objects represents genuine technological advancement that validates our space exploration infrastructure and decision-making processes. Yet this rational perspective misses the crucial distinction between technological capability and cosmic wisdom. Atlas might have been testing not just our ability to detect and study interstellar visitors, but our capacity to recognize when such encounters represent warnings about threats we haven't yet learned to understand or defend against. Consider this cosmic warning timeline. Atlas's harmless passage creates false confidence in our ability to handle interstellar encounters, leading to reduced investment in planetary defense research and development. We conclude that our existing Mars monitoring and colonization systems are adequate for any future cosmic visitors, when Atlas's benign chemistry and favorable approach characteristics might have been uniquely non-threatening. The day Final warning forces us to confront the most disturbing possibility about Atlas's encounter, that we're witnessing the universe's attempt to teach humanity critical lessons about cosmic survival, and we're failing to recognize the curriculum because we're not yet sophisticated enough to distinguish between cosmic gifts and cosmic tests. Here's what makes this warning scenario particularly cruel. Atlas provides the perfect opportunity for our species to develop genuine cosmic awareness and planetary defense capabilities without facing immediate existential consequences. The encounter offers all the educational value of a major cosmic threat without the catastrophic outcomes that would force adaptation through species-threatening crisis. But if we interpret this cosmic mercy as evidence that we don't need enhanced defensive capabilities, we waste the opportunity to prepare for future encounters that might not be designed as educational experiences. The final warning transforms Atlas from an astronomical event we study and forget into a cosmic examination that determines humanity's long-term survival prospects among the stars. Whether we pass or fail this test depends not on Atlas's behavior, but on our species' ability to recognize when the universe is offering crucial lessons about the true requirements for cosmic citizenship. What genuinely terrifies me about this warning interpretation is the possibility that cosmic intelligence, whether artificial or natural, operates according to selection principles that give potential spacefaring species exactly one opportunity to demonstrate readiness for interstellar existence. Atlas might represent humanity's only chance to prove we understand that expanding beyond Earth requires constant vigilance against threats we can't predict and defensive capabilities against encounters we can't control. If we fail to learn the right lessons from Atlas's approach, the next interstellar visitor might arrive as an examination rather than a warning, testing our cosmic preparedness under conditions where failure means the elimination of human civilization rather than another opportunity to develop appropriate responses to interstellar threats. The cosmic anarchist delivers its final message not through what it does to Mars, but through what we choose to learn from our first major encounter with genuine alien chemistry in the modern age. The warning is complete. The question is whether humanity possesses the wisdom to recognize that our survival among the stars depends on understanding warnings we receive, not just surviving threats we can see. Atlas forces humanity to confront the ultimate question of our expansion beyond Earth. Are we genuinely ready to be cosmic citizens, or are we still planetary children playing with advanced toys, while the universe operates according to rules we've barely begun to comprehend? What terrifies me isn't the specific outcomes of Atlas's encounter with Mars, but the growing realization that this interstellar visitor might be administering the first comprehensive examination of whether our species possesses the technological sophistication, psychological resilience, and cultural maturity necessary for survival in a cosmos that routinely tests the worthiness of civilizations attempting to spread beyond their home worlds. The cosmic citizenship test reveals itself through every aspect of Atlas's approach. The conjunction period that blinds our observations tests whether we can maintain rational decision-making when cosmic events exceed our monitoring capabilities. The exotic chemistry challenges our scientific frameworks and technological adaptability. The gravitational dynamics test our understanding of orbital mechanics on interplanetary scales. The information warfare potential examines our psychological resilience during crisis periods, when uncertainty creates opportunities for social chaos and political manipulation. But here's what makes this test truly comprehensive. Atlas arrives at the precise historical moment when humanity is transitioning from single-planet to multi-planet existence, creating maximum stress on every system we've developed for space exploration, colonization planning, and interplanetary survival. The encounter occurs during our most vulnerable expansion phase, advanced enough to detect cosmic threats, but not yet robust enough to defend against them effectively. The examination covers multiple critical areas of cosmic readiness. Scientific competence. Can we accurately analyze and interpret phenomena that fall outside our previous experience? Technological adaptability. Can our systems function effectively when confronted with variables we didn't anticipate during design phases? Economic resilience. Can we maintain investment and political commitment during periods of cosmic uncertainty? Social stability. Can we preserve rational discourse and evidence-based decision-making when faced with existential questions about our species' expansion beyond Earth? But perhaps most importantly, the cosmic citizenship test examines our wisdom. Do we understand that expanding beyond Earth exposes our species to categories of threats that planet-bound civilizations never encounter? Are we prepared to develop and maintain defensive capabilities against cosmic encounters we can't predict or control? Can we distinguish between cosmic warnings designed to educate us and cosmic threats designed to eliminate civilizations that aren't ready for interplanetary existence? Let's examine what passing the cosmic citizenship test might look like. Humanity recognizes Atlas as the first of many interstellar encounters we'll face during our expansion beyond Earth. We develop robust planetary defense capabilities, exotic chemistry analysis systems, and space-based monitoring networks capable of detecting and responding to cosmic threats decades before they pose immediate dangers. We establish interplanetary civilization with built-in resilience to cosmic encounters, communication blackouts, and exotic contamination scenarios. Passing the test means transforming from a species that reacts to cosmic encounters into a civilization that anticipates and prepares for them as routine aspects of multiplanetary existence. We develop economic systems that remain stable during cosmic uncertainty, political frameworks that make rational decisions despite incomplete information, and cultural institutions that maintain social cohesion when confronted with existential questions about our place in the universe. But here's what failing the cosmic citizenship test might involve. We interpret Atlas's encounter as evidence that interstellar threats are manageable using current capabilities, leading to complacency about planetary defense. We allow economic uncertainty or political manipulation during the conjunction period to undermine long-term commitment to space exploration. We fragment into competing factions arguing about cosmic threat interpretation instead of developing unified responses to interstellar encounters. Failure could manifest as abandoning Mars colonization due to overreaction to minor anomalies, or proceeding with colonization despite ignoring genuine warnings about cosmic vulnerabilities. Either response demonstrates that we lack the balanced judgment necessary for making life-and-death decisions about our species' expansion beyond Earth's protective systems. The cosmic citizenship test becomes truly profound when we recognize that it's examining not just our current capabilities, but our potential for continued development as a spacefaring civilization. Passing doesn't require perfect responses to Atlas's encounter. It requires demonstrating that we can learn appropriate lessons and adapt our approach to cosmic encounters based on evidence rather than fear or wishful thinking. What makes Atlas's test particularly significant is its timing during the narrow historical window when human civilization possesses adequate technology for interplanetary expansion, but hasn't yet developed the cosmic awareness that characterizes genuinely mature spacefaring species. The encounter could represent our graduation examination from planetary to cosmic citizenship, with results that determine our species' survival prospects for centuries to come. Still, the optimistic interpretation suggests that humanity has consistently demonstrated remarkable adaptability when confronted with existential challenges. Our species survived ice ages, volcanic catastrophes, pandemic diseases, technological disruptions, and numerous other threats that eliminated less adaptable life forms. Atlas represents another test that will drive innovation and cultural evolution toward greater cosmic capability. But this evolutionary optimism assumes that our previous survival experience on Earth provides adequate preparation for the challenges of cosmic citizenship. Atlas might be teaching us that expanding beyond our homeworld exposes us to categories of threats that require entirely new forms of technological and cultural adaptation. The cosmic citizenship test ultimately examines whether humanity can make the psychological and cultural leap from thinking like a planetary species that happens to have space technology to thinking like a cosmic species that recognizes interplanetary existence as our natural evolutionary trajectory. Here's what genuinely terrifies me about Atlas's examination: the possibility that we're being tested on material we haven't studied yet, using standards we don't understand, with consequences we can't predict. The Cosmic Anarchist might be our final examination in interstellar readiness, and we're discovering that graduation requires knowledge and capabilities we haven't yet developed. But perhaps that's precisely the point of the test, not to measure our current readiness, but to determine whether we possess the wisdom to recognize how much we still need to learn about surviving as cosmic citizens in a universe that takes no prisoners and offers no second chances to species that attempt expansion beyond their homeworlds before developing genuine understanding of what cosmic citizenship actually requires. As Atlas continues its journey toward perihelion and eventual return to the interstellar void, we're left with the most unsettling realization of all. The Cosmic Anarchist hasn't just tested our preparedness for multiplanetary civilization, it has forced us to confront the terrifying possibility that the universe operates as a continuous examination system where intelligent species must prove their worthiness for cosmic citizenship through encounters they can't predict, can't control, and can't afford to fail. The conjunction period will end. Mars will emerge from behind the Sun. Our instruments will eventually reveal whether Atlas's encounter was transformative or routine. But, regardless of what we discover about our backup planet's condition, Atlas has already delivered its most important message. Humanity's expansion beyond Earth isn't just about developing better technology or building more sophisticated habitats. It's about evolving into a species psychologically and culturally adapted to thrive in a cosmos that regularly tests whether we deserve to survive among the stars. What haunts me isn't the specific outcomes of Atlas's approach to Mars, but the recognition that this encounter represents just the beginning of our species' education in cosmic survival. If we interpret Atlas correctly, as a warning rather than a threat, as an opportunity rather than a catastrophe, as an examination rather than an accident, we might develop the cosmic awareness necessary for genuine multiplanetary civilization. But if we learn the wrong lessons, if we become complacent about interstellar threats or panicked about space exploration, if we allow economic uncertainty or political manipulation to undermine our commitment to expanding beyond Earth, then Atlas might be remembered as the moment when humanity discovered we weren't ready for the universe as it actually exists, rather than as we've imagined it to be. The Cosmic Anarchist has posed the ultimate question about our species' future. If Atlas was indeed carrying a message from the cosmos about humanity's readiness for interstellar citizenship, what do you believe that message was? Was it a warning that we're attempting multiplanetary expansion several centuries too early in our technological and cultural development? Was it a test of our ability to maintain rational responses when confronted with cosmic uncertainty? Was it an educational opportunity designed to accelerate our evolution toward genuine spacefaring capability? Or was it something far more disturbing, evidence that the universe itself operates according to selection principles that eliminate species incapable of recognizing and preparing for threats they can't predict or control? The answer might determine whether humanity's next chapter is written among the stars or confined forever to the single world that gave us birth. Atlas has delivered its cosmic curriculum. The question is whether we're wise enough to recognize that our final examination in interstellar readiness has only just begun. Drop your theory about Atlas's true message in the comments below. And if you value investigations into the cosmic encounters that could determine humanity's survival among the stars, subscribe and hit the notification bell, because Atlas might just be the first of many interstellar visitors testing whether our species has learned what it takes to earn citizenship in a universe that offers no mercy to civilizations unprepared for the realities of cosmic existence.